Going on, Dev?
What up?
How's your Friday?
Yeah, good day.
Oh no.
Yeah,
Have you? Do you know the people that want to shut off conversation? It's terrible, isn't it?
It's
yeah,
horrible.
it's weird. I'll admit that some people don't want to have um, that conversation. Some people just want to naysay. I personally don't get it. Like, we're all here to, entertain each other's ideas at least. So I haven't been following the chat either. I'm at work, so
Oh, you don't need to
I can
follow the
only.
chat here. It's like everywhere.
Yeah.
Flatside, he got rid of us. He doesn't want us commenting in his chat, asking him
Oh,
questions how he
really?
manages to prove that the Earth's flat. STST, I can't fucking comment there. I can't even comment in the chat to let him know that I can't comment. You just get
You want me to
hidden.
let them know?
Well, you've got to be careful, right? Because your mods, uh, they're the ones that do this silencing. You've got to be careful who your mods are because you'll never know, right? You could be getting rid of your viewership because your mods just get triggered. They don't want them people commenting.
Definitely. Yeah, no, I mean, you got to be on top of that, and the YouTube mods are a little bit harder to, keep on top of that. It's all pretty much text based.
Yeah. Nathan Oakley's mods and Flatside's mods are the most fanatic I think I've seen ever. Right? I know Fight the Flat Earth has a way, then there's a lot of people in his chat that are pretty triggered. But man, the most loyal Nathan Oakley's and Flatside's.
Yeah, I guess I've never attempted even to go over and uh, interact with their YouTube chat.
Well, I always find like to see the greater picture, you've got to see what's going on because Nathan Oakley obviously doesn't, he can't talk, right? He can't go out anywhere and have a chat like, most people can. I don't know why, but he
Right?
can't. He can't even allow people to come in and have a chat. So he has these like protectors, people who sort of filter everybody out for him.
Yeah.
And they
That
have an
always weirds
ability
me
to
out.
control him, I think, as well. With these people who they allow in and who they don't.
He's got handlers.
Mm.
Yeah, I always find it weird when people like that. They're not able to like leave their safe space. You know?
Yeah, like B-Ball, what's up with him, man? Look at that. You know how big his folder is of stuff that I've done.
Yeah. I
Yeah,
mean, he
but
doesn't have.
shouldn't he be busy doing military stuff?
That picture there, right, that he's got thanks Bev on. That's my
Hmm.
lad. He should say, thanks Bev's lad. Thanks Bev for driving his son to the place to replicate the picture that Ranty got given and stared at for 2,000 hours. Should say thanks for just replicating it, saying, yeah, there's nothing different there. It's a good picture, isn't it?
Yeah,
After
it shows
Ramsey
the
photoshopped
hemisphere,
it.
innit?
Yeah. Because we went there, right, to show, particularly, that, see the way the shadows are on that, the mountains in the background, the sun's on them, right? So that's sunset, isn't it, on the mountains? You can see the sun's coming down over there, over the Isle of Man. It's just going down right now. And then there it is. And we went there to show how lit up Blackpool and Lytham St Anne's seafront is at that time of night. As you can see in the picture that Ranty's darkened. All of that's lit up because the sun's there.
Did you guys use the same camera?
No, he's got a different camera. But, I mean...
Well, that might add bright or color effects to it as well.
Yeah. But we were just pointing out that the Blackpool in the picture has got a mist on it, so that's an early morning Blackpool, and the mountains and all of that in the background is a sunset. But everybody seemed to miss that. They wrote "Thanks, Bev" on it, and Ranty just fucked off. Never to be able to talk about it. It's really weird, isn't it? That sort of stuff happens.
Ranty was the flat earther, and that this is the image that turned him globe.
Yeah, I think Katz gave it to him. It's just a picture off the internet. But it was taken from where we've filmed all of the Fata Morganas. And, you know, Ranty said, "Wow, look at that. It's a globe." And I went, "No, that's what we see all the time, Ranty. You're meant to be an expert photographer. And yet it's just across the bay. You live in Blackpool. Like, how could he... He knew that all along. I don't know what sort of a play it was that he decided to do. But it wasn't because of that picture. Maybe he went mad or something. I don't know. Maybe there's a thing going around where people go crazy. Maybe he got a fair bit of money. Maybe his 5-year service was up.
Yeah, he got paid off, or yeah, he's got a pension plan now.
Well, Sleeping Warrior did bring him and Katz in. And I suppose if they both got brought in at the same time, then Ranty got the bum end of the deal, right? Because he was the one being the flat earther, and Katz is the one that got to pretend to be a teacher. Didn't he? He got all the adoration of the globe, whereas Ranty, he was the butt of all of the jokes. Until he switched, and then everything was fine. He was great. Everybody loved him. Dead weird.
Ranty got convinced by this because from the observation point of the distance, the top of Blackpool Tower cannot be where it is in relation to the mountains in the background when calculating perspective. It just can't.
Calculating perspective?
Yeah, double distance, half the size, that kind of thing.
Oh, yeah, but how do you calculate anything? It's just a picture. Like, I mean, I don't understand what you're calculating.
Basic trigonometry. You know the distance.
How many hours?
From a
If you know
picture,
the distance and height of something,
you've got no angles. You've got nothing. You didn't even know where he took the picture from.
If you let me finish. If you let me
Hold on,
finish.
Bev. Yeah, let him get it. Yeah, let him get it all the way up, Bev.
Yeah, so despite what Neanderthal cave flat earthers would have you believe, if you have the field of view of a camera, the distance of an object, you can work out its size, because you can work out the angles based on the vertical pixels in relation to the vertical field of view. Based on the distance, you know its size.
Cameras don't measure angles, though.
This is what?
Cameras don't measure angles.
Who said cameras measure angles?
Well,
Cameras
it's just a picture he
have
found
angles.
off the internet.
Cameras have angles, Bev. They have lateral and vertical field of fucking view. Regardless of whether they have a measuring stick on them or not, the top to the bottom of the field of view of a camera is an angle. It is measured in degrees.
Do you use the aperture size as well for that, or do you
No.
use the field of view?
Well, I say irrelevant. There's something called aperture and focus. Normally do not alter the field of view on very high-end cameras. They do on lower-end cameras. So, for instance, you can have something called focus breathing, which does very slightly alter the field of view. But a lot of modern high-end cameras have what you call focus breathing compensation, which actually just eliminate that.
So he got a picture, and then he did what? Like, that was the bit that we never really got explained, because I think Ranty could explain it. He wasn't a very good... he just looked at it. He wasn't a geometer at all, is he, Ranty?
No,
I mean, he wasn't even a mathematician. He didn't know anything.
He just looked at it. He literally just looked at it.
You don't have
500
to be a
hours.
So here's a question then, Bev. If I'm 6 feet tall and I'm looking at a lamppost that's let's say my eyes are 2 meters high, and I'm looking at a lamppost 20 meters away that's 22 meters high. Do you think it is possible to know how much I'd have to look upwards to look at the top of that lamppost? Do you think that's possible with that?
You don't
data
even
that
know
I've
where
seen?
the guy took the picture from.
No. This is an example to demonstrate.
No, this is an example of what you're supposing Ranty did.
Yeah.
You're giving us a non sequitur example. Let's just use
Yeah,
the
it is.
picture that we're talking about.
All
It's
right,
there.
So you need to know approximately where the picture was taken, which, surprisingly enough, you can work out the elevation and where it's taken from the top, from 2 points. You can figure out the angle. So if I look at the, I mean, I could do it now for you.
So what elevation was it taken from then?
They'll probably, well, wait a minute, let me have a look. Which are we? We're on about the one that you, the Earth is Live posted, yeah?
Yeah, the one about the one picture that turned ranty.
Yeah, that one that says thanks, Bev, yeah?
The one that he's put thanks Bev on, yeah.
Yeah.
Other than me driving my son to take the bottom picture, the top one's in an art gallery. It's a paid thing you can buy. It's a photographer has put it up there. It's not just a random picture he's taken. It's actually in an art gallery. So it's been touched up by an artist, right?
Well, when you say touched up, that depends what you mean. And you'd have to.
It's like I was saying, the mountains are at sunset, and the early morning mist is a sunrise. That's why it's dark. The sun's over on the other side. Completely different. Blackpool and the mountains.
Say that again. You're saying this image was taken, and the background was taken at a different time than the foreground, correct?
Yeah, it's a composite.
Yes. So how did you determine that then?
We went there and took a picture of it at sunset and showed that how Blackpool front. It's all glistening. All of the lights gets reflected from the fronts of the houses, and it's all on the sand dunes. But in that picture that you're looking at, it's dark. It's got mist on it.
I'm going to have a look at what angle this was and see what you just said is true or not.
That's why we went to go and take the picture, just to check. Because I said to these guys, I will go down there tonight and go and take a picture. It was pretty much when they took that picture. Because I said, that's where we did all of the Fata Morganas. In fact, when I went down there and I did the first Fata Morgana, I tried to tell Ranty to get out in Blackpool and see if he can see it, film it. He didn't, so he missed out. And he's never, I don't think he ever filmed anything like that.
So what you're saying is this is the top picture, which you've got a problem with, is sunrise. It's early morning, correct?
No. We were told, right, that this guy was just out for a walk and he took a picture along the trail. And we went, nah. Well, we go and have a look, eh? We'll go and have a look. So we went there to have a look and to replicate that picture. And we found out that he wasn't on the trail at all. So that was a bit of a lie. And then we tried to get in touch with the guy. And I showed Ranty. And Ranty highlighted it and said, thanks, Bev, for supposedly turning Ranty. For, he changed it. He darkened it. He did all sorts of his fancy photography stuff. Whereas we just went there and took a picture to find out where the guy had took the picture. Because you could actually replicate it, right? From a certain position.
Yeah, you should be able to.
Yeah.
Yeah, so it does look like that. That is at sunrise. And
where?
You are correct. At sunrise, that picture on a flat Earth would 100% have to be doctored.
No, that's
100%
sunset.
Has to be doctored.
The mountains, the sun on the mountains is sunset.
Oh, so so now you're saying it's sunset on the mountains?
Yes.
So
that is something that we can say for sure because you can see the shadows, right?
So you're saying when we look north and it looks like the sun is coming from the left and casting shadow to the right, that's actually sunset on a flat Earth, right?
I don't know what you've got to do with flat Earth. Like, in reality, the sun is going down to the left, right? Now, the sun rises in the right.
Oh, got you. So on a flat Earth, it rises in the west and sets in the east, right? Yeah.
I don't know what it does on a flat Earth.
All right. Does the sun rise in the west and set in the east in your reality?
Sorry?
You just said this is the sun's rising in the to the
To
right.
to the right of the picture is where the sun rises, and to the left of the picture is where the sun sets. Now, the sun is going down over the Isle of Man in that sort of picture that you're looking at, because you can see the shadows on the mountains.
So I've got a question about the first statement. Are we looking from this picture? Are we looking north or south, do you think?
It's looking north.
And you're saying it sets by going over to the left.
The sun sets over the Isle of Man. Yes, on that side.
Okay.
It's
so
we're in the northwest, right?
So if the sun's on the left, you're saying this can't happen to not illuminate Blackpool, right?
We went there to take a picture at that time to show how lit up Blackpool and Lytham St Anne's front gets. Yes. Now, in that picture that you're looking at, it isn't lit up. It's pretty dark.
Right,
now, unless you know anybody else that's ever been there to take a picture to replicate it, then you're free to talk to them. Bring them out. Let's see.
No, I get you now. I get you now. Right, so it's looking north, not looking south, and your contention is you can't have shadow over Blackpool while you've got illumination. Like,
it's not a contention. I'm just telling you. Look, that somebody took that picture,
away.
right, and then they said, "Wow, that's a proof of a globe," and we went, "I don't know. There's something about that picture. It's a very nice picture. All right, a very arty picture. It looks beautiful. It should be in a gallery, and yes, it is. It's in a gallery." Right? We were then also told that the guy just took a picture as he was on the trail, taking a walk. So we went, that's where we go to take pictures. That's where my son practices his long distance photography. In fact, you can see the Blackpool stones in that picture.
Yeah, no.
Right, now that's where DP had his laser when we were doing laser waving, right? We asked Ranty if he wanted to do it as well. He turned it down. He turned down all of the things that we asked Ranty if he wanted to do. Strangely enough, he didn't want to do anything. He was on his own, right? So we went to go and check out, and we found out, right, that he didn't take the picture from on the trail. So do you know the elevation of the guy and what elevation he was for your calculations in the picture?
I would say the camera height is in between, let's say, 6 foot off the water level and 30 foot water level. That'd do.
Between 6 foot and 30 foot?
Yeah, I'd hazard a
You mean mean sea level or the actual water level?
The actual sea level that's near Blackpool, whatever that would be.
The actual? Like, you mean what time of the tide is?
Yeah. I mean, the variation, the variation in between, let's say, 6 foot and 30 foot would produce an error tolerance or a margin of error when you're calculating the parallax in the background that you'd account for.
But you're making that relative to the water, though, are you?
Wait a minute, we're nearly done. That you could calculate to see if it was done. But I want to go back. You said this is obviously...
No, wait a minute, I've not finished yet. You said you've got an error tolerance of between 6 foot and 30 foot, was it?
Yeah.
Right, now, that's relative to the water, as you say. Now, do you know at that place there's a 10-metre tide? So are you going to factor in that 10 metre into your already 30 foot?
No, because
No.
I
Is that
just say
that's
they're stood on-
why you've
no,
got the
okay.
error then?
Let me know
Is
when
it?
you're done.
Is
Are you
that
done?
why you've got the 30-foot error because of the tide?
No.
No.
Are you done? No,
So
it's because
that's
I couldn't be asked working out exactly where they are. But I can see that they're on marshland, and I can get the elevation of that land independent to the fucking ocean level. But the 30 foot or 20 foot would just be, oh, I'll just make sure there's error tolerance built into this. And if flat Earth can fit in the minimum, that'd be awesome. But it probably won't. But I was more interested, Bev. You said this is doctored anyway, so it's pointless until we figure out is it doctored or not. It's pointless trying to work out any survey.
It's in a gallery. It's a photographer. Of course he's done it. He's touched it up. Of course he has.
Whoa. Calm down.
I'm not,
Okay.
dude, it's
So
nothing to do with
I
that being
didn't
calm.
say-
It's in a gallery.
I didn't say it's not in a gallery. Well done. Okay, so it can be and it can't be. Utterly irrelevant. Thanks. And I didn't say anything else about whether a photographer took it or not. Again, utterly fucking irrelevant.
No, you're talking about the mathematics that you can do from the picture.
This image doesn't look right, and then you stated the background and the foreground aren't the same image. And I'm saying to you, well, that's fine. But in order to have that assertion, you would have to say that the background, if lit, cannot be different to the foreground that is not lit. And is that your claim?
I don't know what you're talking about. I'm saying we went there to take a picture to show that at that time of night when the shadows are like that Blackpool Front is lit up by the sun because it's obviously lighting up the mountains.
Oh, awesome. Right. Okay. So based on that premise, you're concluding that it's fake. Am I correct in that? Or it's doctored or it's composite. Am I correct in that?
I'm just pointing out that it's a photo in a gallery took by a photographer and touched up, brushed up. Yes, of course it is.
All right, so you don't think that both the foreground and the background were taken at the same time, correct?
It's dude, I haven't got a clue. Like, find the guy.
Now we don't have a clue. Okay.
See, I'll say it again, Stingray. We went there to replicate it. And then we showed Ranty the picture to show him that Blackpool and Lytham St Anne's seafront is lit up. What Ranty did then was darken the picture and put it on the otherneath bit and said, thanks, Bev.
Yeah, I hazard a guess that whether cloud cover was covering the light on the mountains or covering the light on Blackpool, but not both, is utterly independent to you working out the angle where your observation point, the top of Blackpool Tower and the intersection of the mountains...
Can't measure angles with either an auto level or a camera.
Okay, let me know when you're done.
Yeah.
The two are utterly irrelevant and independent to...
Yeah, your angle thing's a complete non sequitur. We were talking about taking a picture.
Yeah, you can work out angles from pictures, Bev.
I can't.
Well, that's you're failing. I could teach a small child to in the next 10 minutes.
You could like put a ruler on a picture and get an angle from it.
Oh God, yes, that's almost what I said, word for fucking word. Your hearing is next level fucking genius, isn't it?
Well, you've got a 2D picture. You can make a line out of it. I mean, that's about it. And then you can represent that line as an angle. Do you reckon?
It's like you're just repeating what I said.
The opposite side angle. That's a Ruhif thing. Did you teach Ruhif?
You could just ask me how, you know.
Make sure you guys aren't stepping on each other. Please, Bev. Just let him finish. Stingray. Let him finish.
So if you want to know how, Bev, you get the focal length of the camera. It's most likely given in equivalence to 35 millimeters. Then you work out the field of view, the lateral field of view from that. You can even, if you really want it to be incredibly accurate, I'm talking like within 3 percentile accurate, you'll be able to get lens distortion maps from the manufacturer as well to correct for pin cushioning or barrel distortion. But once you've got that and the resolution of the sensor, based on pixels now, you can work out the degrees, the angular size of something. And if you know the distance to it, you can work out its physical size as well. Because it's easy to say that if a camera lens has a vertical, we'll make it easy, 45 degrees vertical angle from the bottom of the lens to the top of the lens, and something is, let's say, 20 meters away, and it takes up half the frame, we know that it's 40 meters high. It's really simple.
Does that work for every image? You don't have to know what the camera sensor or anything like that.
Well, the brilliant thing about lenses is they're given in what you call equivalent focal lengths. Yeah, so you can have the different size sensors, and they're all given equivalent to 35. You might have to do a little bit of tweaking because you have like Super 35 or APS-C or even medium format. But at the end of the day, with the focal length and the sensor size, or the equivalent focal length and the actual sensor size, along with the resolution, what you call the open gate resolution or the frame resolution, you can work out the angular size of something to within a degree of accuracy that a pixel takes up, obviously.
There you go. How about that? Is that another picture? What sort of height is it? What angle would you give that?
You'd have to tell me what camera it was.
iPhone.
On which lens? There's which iPhone basically, and which setting of the lens, because you can have
like say a good iPhone. Just give us an estimation.
Well, yeah, you have to. Well, the estimation.
What was the estimation of the angle from that other picture? I mean, would it not be comparable to that?
No, I'd need to know. I'd need to know the lens.
You need focal length. You need focal length and sensor size, or equivalent effective focal length.
Yeah. Now you're saying iPhone. Well, brilliant. It's got 3 fucking lenses. Pick one and tell me the. And actually, believe it or not, those lenses across different iPhones are different. So one's got a 22, one's got a 24, 35, and.
Will we get a different angle?
Sorry?
Will we get a different angle?
Well, out of all those different fields of view, yes, by quite a margin, by quite a factor.
Okay.
I need to know which focal length this is taken in. If you give me the raw image, it'll have it baked into the metadata.
Well, what was the one from the Ranty thing?
Oh, I don't know.
What, you don't know? Oh, do you think Ranty did that then? Do you think Ranty worked out?
Absolutely. But believe it or not, it's not like you need to know. To do a point-to-point observation, there's no size of anything. You just need to know the approximate distance and your elevation. Now I can say, well, if I project from the sensor or from the camera to hit the top of the Eiffel Tower, to hit the back of those mountains,
it's Blackpool
how high
Tower.
will that be where the mountains are? And are the mountains higher or lower? And where should they be? And that's what Ranty did.
It's Blackpool Tower.
Yeah, Blackpool
we know that.
He just said the Eiffel Tower.
He misspoke, Biff. Stop being a twat.
Well, I was just making sure. You don't want people thinking that that's the Eiffel Tower.
Thinking I got it wrong. He just lost his gold card.
Fuck you, demon. Fuck you. Yeah, so the Leaning Tower of Pisa, if we fire at the top of it in that image, we can work out where that line should intersect on the mountains behind it. And we don't need to know the focal length for that. We just need, because it's a point-to-point, we just need observer height of the Eiffel Tower, and height of the mountains, along with distances, and that's it. And I think what Ranty did, Bev, was look at that and say, well, actually, with the height of those mountains, the observer height, and the height of the Leaning Tower of Pisa, that intersection line should hit the mountains, but it doesn't.
Ranty did what he was told. Come on.
Okay, for any flat earther to be converted to reality, that's what they would do. That's it.
His time served. It was up. They all felt sorry for him. It's It's like they've
is
been
flat
making
Earth
fun
like
of you
a-
for too long,
Flat
Ranty.
Earth is like a prison sentence, is it?
I was gonna say, who decides how long people are supposed to be in flat Earth for? Do you think there's somebody in a higher up that's like in charge of that?
And who's
He
on
did
that parole
5
board
years.
as
He
well?
did say that. Ranty said it. He said he's been doing it for 5 years now. He's got nowhere. His time was up. That was Ranty's time. 5 years.
Did he serve his sentence? Did he
Well,
serve his
I don't know. I
What is
don't
it?
know whether it's some sort of initiation to the club, like a humiliation ritual, perhaps. I don't know.
Did
He was
serve
put on
full term, or
probation.
did he? Was that parole,
Yeah.
or did he? Was he?
Yeah,
released
he got
early, or-
probation with time served. Yeah.
Well, he took
Yeah, maybe
on
he
a
got off
nice
for
trip
good
with
behavior.
cats, didn't he?
You know, Bev, maybe you can get off for nice behavior too.
Get off for what?
Get off of being a flat earther.
I'm
You know,
not a
what's that
flat
gonna happen?
earther.
For nice behavior, yeah.
Yeah, but yeah, if you have nice behavior, then you're not a flat earther anymore.
The
As it is
flat
now.
earthers hate me.
Oh, I mean, it's kind of sad, isn't it?
Did you
Flat
ever
earthers think
consider
everyone
the
else
Earth to be
can do.
flat?
No,
Like, was that ever
no.
okay? And so you are just Earth shape agnostic then? You're just not sure what it
It's
is.
just reality, right? I don't know the whole, so how can I say that? But I mean, I have done surveying, practical geometry. There's no shape that fits it. It's definitely not one of the platonic solids. There's like no
Right.
shape that would fit. So asking
Do you-
about shapes
do you think-
is fucking ridiculous.
Do you think
really.
the Earth was? Do you think the Earth was created by a creator, or do you think it was a natural process?
I wouldn't know. Far beyond me. Not for me to worry about that sort of thing. It's never something I've wondered about. So therefore,
Yeah.
Do you think that you don't strawman flat earthers when you think that they say that the Earth is actually a plane with no topography?
no, I'm just telling them it's not flat. It's not a straw man.
Sure, but
So it's like
so
a
you
statement
don't
of
think the
fact,
flat
like
earthers
it's not
actually
flat.
say that the Earth is flat?
When they
Sure, and
say
you don't-
flat, they think horizontal, right? And if you've
No,
not
no, they
realised
don't.
that,
No,
then
they don't.
yeah, they do. I've had a word
they-
with them this
So
morning.
you think?
They think
you
flat
think that
is
they-
horizontal. QE says it as well.
Okay,
They
so-
think it's an orientation. They're crazy.
Okay, so hold on. So you think that they deny topography?
In order for them to say it's flat, yes, they
Yeah.
must. They must imagine
Okay.
it's 2D, right? They must imagine
Okay,
the
then-
surface of everything is 2D. They're flat earthers, mate.
Okay, so then you're saying that globers also deny topography because globers say it's a sphere, right?
2D, right? Flat is 2D. You don't think the
Okay,
globe
so then-
is 2D, do you?
No, the surfaces,
Okay, so-
because all surfaces are two-dimensional.
We're
No,
not really
flat.
on that.
No. Flat earthers think all surfaces are flat.
No,
2D,
that's just
I
what
2D,
said
you
all
get at
flat.
surfaces are two-dimensional because they have area, no volume.
No, that's 3D. That's the difference between 2D and 3D is
Hold on, Bev.
the
You said
extra
that there's a
dimension.
three-dimensional area. What's a three-dimensional area?
What?
You
Areas
said
in
that the
square
surface of a
units.
sphere
Square
is
units
three-dimensional.
are a square is 2D. It's a two-dimensional shape.
Also,
And the
does
surface
a
of a
sphere
sphere
have a
is-
surface area?
The surface of a sphere is also given in square units, right?
Yeah.
The
because
amount of
it's
surface
two-dimensional.
in square units, right? So how is that 3D?
But the mountains have a surface, and that's not 2D. Like,
surface of the
Nathan
mountain
Oakley
is-
thinks that
surfaces.
mountains are measured flat. You don't think that, do you?
No,
hang
mountains.
on a
Mountains are three-dimensional, but the
There
surfaces
you
are
go.
two-dimensional.
There you go.
Hang on a second. How many degrees of freedom do you have on a surface of a sphere?
It's 10 seconds, Bacon.
Sorry? Yeah, how
Got
many
you on the
degrees of
clock.
freedom?
A sphere
Yeah, how many
is
degrees
a three-dimensional Euclidean solid. 3D.
Sure.
Solid.
And how many degrees of freedom you have on its surface?
A circle is 2D.
Can you answer my question?
Right, so if the circle is 2D, then a sphere cannot be 2D. Because you can't have
You
both
are,
the circle and a sphere being 2D.
Yeah, He might not have heard you. Bev, are you able to hear Bacon? He's asking you, what was it? What was the freedom of movement on a surface or a sphere?
Yeah. Well, how many degrees of freedom you have on the surface of a sphere?
Like a clown circle on a ball. I think he can go anywhere, can't he? Providing there's not the edge of the ring.
Bev, can you hear me? I'm not sure if you're not listening or you're just saying nonsense.
The entire freedom of the circus ring. He's.
Hold on, Bev. Can you hear Bacon? Can you hear Bacon at all?
Bev?
Yes, he can. He just doesn't know how to answer the question.
Okay, that's fine. It sounded, with your answer, you sound like you couldn't hear Bacon. I don't think he's going to be able to answer you.
No, fair enough. I'll stop asking. So
I don't even know how to answer that question. What would the answer be?
Well, the answer is 2.
You have 2 degrees of freedom. However, to
and
make the surface
it's 2, not 360.
That's not a degree of freedom.
That's 1. Well done, Bev.
What, 360 is 1?
No, if you move, we're on about movement.
Yeah, I don't think you're familiar with the concept of degree of freedom. Now you go to Google.
We're talking about a circus clown stood on top of a ball.
You're a little long-winded, Bacon.
Technical mathematics. Don't worry about it, guys. He has to learn his way. Learn the rhetoric.
He has to learn his way. You don't know what a surface is.
I mean, if you're debating whether or not something is 2-dimensional or 3-dimensional, that's pretty much a mathematical term that we have to know what we're talking about.
I'm not sure if you're hearing his argument, Bacon.
What's up with
Sean? All the time.
Well, besides the normal stuff.
That's taking revenge.
I think it's pretty simple. A surface is 2-dimensional because it has an area, and a solid is 3-dimensional because it has volume.
Is the surface of a mountain 2D or 3D?
It's a surface. It has an area, no volume. So the surface is 2-dimensional. The solid.
I consider people who say that 2D surfaces that's flat to me, or a plane. That's what I understand as a plane.
That's kind of your problem, because if I buy land, and there's a
I call
mountain
that
on the land,
Euclidean thinking, right?
Hold on,
Euclidean thought.
Hold on, Bev. We gotta let people finish. Go ahead, Mona.
Yeah, if I buy land, I buy it with area, no volume. Just don't buy a volume of land.
Even if there's hills?
The reason why I was asking about degrees of freedom is that's how dimensions are defined. If it's 3-dimensional, when you have 3 degrees of freedom. If you have 2 degrees of freedom, you call that 2-dimensional. You only have 2 degrees of freedom on the surface of a sphere.
Yeah, but I've got a question on that, Bacon. Coming from an art side, if I take a portion of a sphere and randomly pick any 4 points, that creates a plane, or I can define a plane out of that, but it might not necessarily be planar, which means to represent the portion that will be outlined by those intersections would require 3 dimensions to represent that surface, irrespective of whether I can travel around on it or not in 2D, using a coordinate transform for the surface.
Right, but that makes the space of where the sphere exists 3-dimensional. It doesn't make the surface of the sphere 3-dimensional.
Oh no,
still
I agree.
Yeah.
Well, reality is 3-dimensional, right? Euclidean. So everything within that we understand through that geometry, right? Euclidean geometry.
So here's a question, Bev. Here's another easy way. Have we got an easy coordinate system that we can reference for locations on the planet, on the land that we're on, right? We've got GPS coordinates, latitude and longitude.
Cartesian coordinates. Yes.
So we have got that, but we commonly use
that's what everybody understands, right? Yeah, but I think
Sorry,
the majority of people, if you talk about the coordinate system, you're talking about a Cartesian coordinate system, because that's what everybody will think of. So if you're thinking of something other than
No.
the Cartesian coordinate system. You should really have to explain that.
So if I go, so Google Maps, Apple Maps, or finding a business, how many dimensions am I required to
I think
give
Google's as
someone
coordinate
to
system.
find those dimensions? Is it just 2, latitude and longitude?
Well, grid reference is what I do for maps. That's the best way
Right,
to
so
understand
you've
a
got-
coordinate
yeah.
system. Grid reference.
Awesome. So you've got a map and you've got a grid reference, a 2-dimensional reference point. Doesn't matter whether it's
Absolutely, yes.
topological and so it doesn't matter whether it's topological map
To
or whether
scale.
it's in lat long. Yeah, two coordinates. Does that map represent topology? And why isn't there a third coordinate on that?
They have contour lines, don't they? Or level curves, as some people might want to call them,
Yeah, as
mathematically.
an indicator. But why can you navigate on that with only 2 coordinates?
Within the grid.
Yeah, within the grid.
Well, it just put you a position on the
Like
grid.
on flat
wouldn't
Earth. There. Sounds flat to me.
Yeah, it's definitely flat.
it? Well, squares are only in Euclidean, right?
What?
Squares. Yeah.
What squares?
Squares are
Oh,
a
let's go with it,
Euclidean shape. Only in Euclidean.
Where is it? The shape. It's not a solid. The cube is a shape.
Square, I said. Squares.
Sure.
Yeah.
What about squares?
Well, I don't know. You
Squares.
acted surprised for me to say that a square was a Euclidean shape, because that's what the grids that we're using. So just so people are on board, right? The understanding of the grid is the square. That's
Yeah, I think they told you that in Twitter from who's the one who made maps in UK who you had a discussion with on Twitter.
no, I didn't really.
Ordnance
So you
survey.
didn't.
No, I didn't have
Yeah,
a
or-
discussion with them.
Well,
Yeah, you did.
No, I
For
didn't
the
have a
back
discussion
or
with them.
measure.
They just tweeted something really irrelevant for some reason.
Oh, we
And I
got copies
decided
of it, Biff.
that they were very inexperienced and they
Oh,
didn't
we've got
seem to
copies
know
of
what
it.
they were
They-
talking about. So, yeah, that was it. They
I was
tweeted
thinking-
something stupid and I didn't take it any further.
You not understanding it doesn't make it stupid, Biff.
what's back and forth? So,
Well, they are. Can we go back to the grid, right? The grid reference system of the maps, the 2-scale maps.
I'd rather go back to longitude and latitude.
Are they
Yeah.
are they perpendicular? Is that a 2-dimensional coordinate system?
2
And
degrees
are
of freedom.
they perpendicular?
The very definition of what 2-dimensional is.
Are they perpendicular though, just like the grid lines on a grid reference
hold on.
system?
Earlier you said that the surface is 3-dimensional, not 2-dimensional. Now you're saying that it's 2-dimensional.
The maps, the squares.
Oh, I think he's
Squares are
saying that the
2-dimensional.
surface
I'm
of the Earth
asking
is
you,
2-dimensional, but
is the latitude
here
and longitude
isn't.
coordinate system, is that 2-dimensional? And are those lines perpendicular to each other?
Yes.
Lines for latitude
two-dimensional.
cross lines of longitude at right angles, yes.
Yeah, okay. Just like the grid lines.
And it's
And
2-dimensional.
those maps are 2D as well. So
And
that's
it's
the same.
2-dimensional.
The 2-dimensional is the same. Perpendicular is the same. What's the difference?
The curvature
Where? Curvature of what?
The
of the
sphere we
space.
live on.
One is a flat space, the other is curved space. One
But
is
they are
Euclidean, the other is
perpendicular still.
non-Euclidean. Yes.
And 2D.
Yes.
Hmm.
In a non-Euclidean space.
Wow.
Spherical
Yeah, if
surfaces
they'll-
are non-Euclidean, Biff.
If those were Euclidean, then those lines that are perpendicular to each other on a grid system would form like a rectangle. But they're not. They're not on flat geometry, so they don't have to do that.
So perpendiculars that don't form a grid system.
It's not a flat grid system.
A 2-dimensional grid system.
It is 2-dimensional,
It is a
but it's not flat.
2-dimensional grid system.
Yeah, but it's not flat.
but it's not square.
Your conclusion
Is that what you want to say?
right, because it's not Euclidean geometry.
It's a two-dimensional grid that isn't square.
Exactly. That's how it works
That doesn't
when
really
you
make
have
sense.
positive.
But can you explain
Right,
how you can
because you're
make that
thinking-
make sense? Because it does sound like nonsense, right?
It is nonsense in Euclidean geometry, which is not the case because a sphere, the surface of a sphere is not an Euclidean space. It's a space that has positive curvature.
But the sphere is a Euclidean thing, and you did say it was three-dimensional, right?
Yeah,
No.
the sphere itself can be described in Euclidean space. Its surface doesn't. Its surface is not an Euclidean space. If you're talking about the space of the surface, that's not the same space where the sphere lives in. The sphere lives in three-dimensional space. Its surface is a two-dimensional space that is non-Euclidean because it has positive curvature.
Sounds
I
ridiculous.
mean, understand right, because Euclidean is the default. It's the intuitive one. Non-Euclidean is not that intuitive, so it's a bit nonsense if you don't know anything about it.
Well, could you have a sphere on a plane? Like imagine a ball.
No, you can't.
What, you can't have that? What do you mean? You can though, in reality, right? When people are imagining this, let's say they're imagining a marble and put it on a piece of glass. Right now, the piece of glass, is well, that's as close as a Euclidean plane as you could probably get, right?
Are we ignoring the thickness of the glass?
Well, are you ignoring the thickness of the ball?
Yes.
No.
Actually,
I
we
mean,
are.
if you're talking
yes
about
or no?
If you're talking about the surface, then yes. If you're talking about the ball, then no.
Okay, so if we're talking about it mathematically, the Euclidean plane being the sheet of glass, and then the non-Euclidean plane being the surface of the ball.
That's not a plane.
Yeah, they do. That's yeah. Did you not watch the Veritas video?
Non-Euclidean space. That's non-Euclidean space. I wouldn't call that a plane.
Yeah, you have to consider the surface of the sphere as a plane.
Why? I'm not sure if that follows.
What? Have you not been doing enough work on non-Euclidean?
I have.
Okay.
Well,
so you should know then, in spherical geometry, you consider a point, 2 points antipodal. You consider a line as a circle, and the plane as the sphere. That's non-Euclidean geometry, right? But I'm asking you now, the Euclidean plane, does that, can you have a space where there is the Euclidean plane and then the non-Euclidean plane where they meet? Euclidean, non-Euclidean.
Are you asking if you can intersect a sphere in a plane?
Well, no, the sphere is a Euclidean three-dimensional solid. We know that.
Right, but not its surface, right? Its surface is a non-Euclidean space. So are you asking if you can intersect a non-Euclidean space of a sphere surface with a plane?
Well, we could have the Euclidean ball, 3D ball, on top of a piece of glass. Right? In reality.
Okay.
Now, perceptually, in your mind, we know, right, that when you're looking at that, that is a three-dimensional Euclidean solid. It's a ball. And we know that it's a piece of glass representation of a plane.
Right.
Right. Now, those two are touching each other in reality.
Well,
is that the meeting of Euclidean and non-Euclidean?
The question didn't make any sense to me.
Or could you have the meeting of non-Euclidean and Euclidean just within the sphere? Because the moment you make the sphere, you've supposedly made a non-Euclidean surface somehow. I'd say it's a three-dimensional sphere that makes up it, but you want to turn that 3 dimensions into 2.
Yeah, the surface of a three-dimensional object is three-dimensional.
Nathan Oakley says the mountains are measured flat.
If you The surface of a three-dimensional object is two-dimensional. If that's what you're saying, then that's correct.
Sounds like you're supporting
Uh,
Nathan Oakley. I hope he's recording this.
I
He'll
don't
love
really
it. It'd be
care
something
if
for him
what
to
I'm
come
saying
back
is-
to this. See?
I don't think it's
Is that
relevant.
Bacon? Bacon supports me. He says that the mountains are 2D. Flat. He'll say
No.
flat. He will say flat.
Surface. The surface of a mountain.
But
The surface
even
of
though he
whatever.
says he means
Let me
horizontal,
just
right?
finish, please. Hey, Bev, let me finish, please.
Would
The
all
surface of
points be
any
horizontal?
The surface of any object has one less dimension than the space in which the object lives in. So in a three-dimensional space, a three-dimensional object has two-dimensional surface. Just like a two-dimensional object in two-dimensional space has a one-dimensional surface. It only has length on its surface.
Would
Like a
all the
circle.
points of your two-dimensional surface, would they all be horizontal?
In what
There
example?
would be no there would be no third dimension to dictate that. There is only lateral X and Y, no Z.
Yeah, it never is in 2 dimensions, is there? You don't have a vertical.
so
but I
yeah.
mean, so would that make it everything horizontal then?
Horizontal is irrelevant. You're not in 3D space. You're in 2D
At each
space.
point. It's only
Yeah,
at
well,
a point.
every point is also missing the other coordinate.
No vertical. So in the absence of vertical, doesn't everything have to be horizontal? Every point have to be horizontal and within the 2-dimensional surface that you've got.
Horizontal is a relationship to something. What
The
would
surface.
2 points that all miss the third
Every
dimension
point of the surface.
have? Sorry.
Every point at the surface.
Yeah, you could every point has 2 coordinates. It's like saying,
Well, could you not
you
put
know,
a vertical
very-
at that
it's
point
like
and then
it's
say
like
that's the
saying-
point where the
it's like-
horizontal's
it's like
horizontal?
saying- oh my god! It's like saying it's the difference between the water surface and the water. The water is a volume. It is 3D. The water surface has no third dimension.
So it would be horizontal then, right? Because the water level is known as a tool for establishing a horizontal. So in relation to all the points on it, that would be horizontal. Is that what you're doing? Are you confirming that all points on this 2-dimensional surface
If you
are
can explain
horizontal?
to me how a relationship between 2 points with 2 coordinates each, 2 independent points, we'll call them A and B. If you can describe to me what would constitute horizontal between A and B, I'll tell you.
If you get a water level, right, and neither point being higher nor lower than the other point, would constitute as them as being
Which
horizontal,
dimension are you saying is higher or lower? Is it the X or the Y?
with neither of them, the points in reality, the water level.
The water level sits in 3D space.
Yep.
Can you get me
And
a
the
2D
points
water
at each
level?
end.
2D water level?
I don't know. Isn't the surface of everything 2D according to you?
Yeah, so but the
Well,
problem
there you
with
go
your
then.
water
There you
level,
go. That water
But the
level that you're talking about that I consider in 3D, you can consider it as a 2D surface of a water level that exists in 3D space.
Except now the bubble level of that, which would represent an orientation in the dimension that we're missing, is absent. So all we have is a line between 2 points now that tells us nothing about this supposed horizontal relationship between the two.
Yeah, it's a relationship between the 2 points. One being neither higher nor lower than the other.
Which dimension are you
No slope.
considering to be elevation? Is it X or Y?
It would be considered, you could check that as your datum. You could take 1 point as your datum, and then you could say, according to this reference point, this other point over here is neither higher nor lower than this datum point that we've established.
Okay, and when you say
That's the idea
higher,
of a level.
and if you say higher, which direction are we on about? Are we on about the X or the Y direction?
That would
being
be
the height?
vertical, perpendicular. It would be the Z, I would consider it.
Oh, right, yeah, so in 2D space, no Z, sorry. That's the point we're going to get to.
Yeah, so it's horizontal then, right? If there's no vertical travel, then it must be horizontal. There being no slope, no vertical change.
That's like saying if something in a universe without water, well, no,
It's not like saying that as well. That sounds like a massive non sequitur, if you ask me.
Wait a minute. You can't say something is something when it has no ability to be something, but the absence of it being anything, the negative, means it must be that, even though it still has no ability to be that, especially when you're talking about just two 2D points. They can share the same Y.
A point is 0D, isn't it?
The same,
mathematically.
nearly done. They can share the same Y.
Definitely not 2D.
They can share the same X. They can share the same X and Y. Now, if you consider any of those three conditions horizontal, fill your boots.
Yeah, the entire XY plane.
Say again?
The entire XY plane. Neither higher nor lower. All points, neither higher nor lower, would make the entire XY plane horizontal.
Again, in that space, there is no height. So to say, oh, they're all at the same height when there's no height is a bit weird.
Really?
Yeah, really, really.
There would be no deviance within the vertical for you to be able to measure it. You think that's strange?
In a 2D coordinate system, no.
That is how they measure elevation, though, right?
It's like looking at a cartoon and going, oh, these are all at the same fucking depth. So therefore, everything here must be parallel. It's like, the fuck are you on about?
You just need one coordinate for an elevation, don't you?
Well, you need, well, adding to the 2D coordinate, yeah. And then you'd have a 3D coordinate, yeah.
Yeah. So the elevation, the vertical, is just measured on a one coordinate type thing, which you add to the other two, making it 3D, right? So that's good.
Yeah. Then we do a space transform.
That's how we know it's not flat, right? Because the XY would be a plane.
We're no longer in 2D. We're on 3D.
3D, yeah. But you guys think that it's all 2D, even when there's that extra elevation thing. Much like the flat earthers.
You know, Bev, I've got a little bit of a question for you. I was on my mountain ridge, and I set up my level. I looked straight across the valley, and there was a radio antenna almost exactly at my horizontal. Does that mean it's the same elevation as me?
You set up your auto level?
Yes.
Or was it a bubble level?
Well, it's a manual indexing level, but they're fundamentally the same thing. So yeah, auto level, manual indexing level.
Yeah, not quite an auto level. Right, and
well,
how far away was it? You were on top of a mountain, because that's not usual, that, right, Larry? We normally say people like that for Ranty. Ranty does that sort of stuff.
No, that's quite normal. There's no problem. It's quite normal. I mean, the radio antenna was only 28 miles away.
Only 28 miles with an auto level on a mountain, Larry.
On my manual indexing level, yes, which is fundamentally the same function as an auto level. Yes, that's exactly right. And it was at my horizontal.
And what were you doing?
Does that mean it's the same? Does that mean it's the same elevation?
What were you measuring?
Does that mean it's the same elevation as me?
No, I wouldn't say so. No, I wouldn't say you can't really perform elevation measurements with an auto level from 28 miles, but do you?
Well,
I never had to do any of that sort of stuff, Larry.
Okay. Well, I do. So I then set up my theodolite and I measured
Did you measure that with the? No, wait a minute. I want to know about the manual auto indexing level. What did you measure?
I was going to say that. I was going to tell you that until you started talking on top of me. You'll have to give me a second.
Yeah, what is give
Jesus Christ. Never mind, Bev. Never fucking mind.
That's not me.
Yeah, okay. Hold on a second. Yeah, go ahead and give Studo a whole 45 seconds to try and get his thoughts out.
Yeah, I set up my auto level on this mountain ridge, and the radio antenna was almost exactly at the crosshair. So I set up my theodolite, and I measured the vertical angle to the radio antenna, and it was down just a little bit down, not even a quarter of a degree down. And the radio antenna is 400 feet higher in elevation. So how can a radio antenna that's 400 feet higher in elevation be slightly below my horizontal at 28 miles? Would you explain that, Bev, please?
I can't even explain why you went up a mountain to look at a radio tower with an auto level, Larry. So I haven't got a clue. You should really write it up or something. Put it to paper or something. I think. Yeah, I've always said that you are the last of the great globe surveyors, Larry. I don't think there's ever going to be any more people.
And the reason I went up on that mountain ridge to look at the radio antenna 28 miles away was to determine its elevation by vertical angle. And I was only in error by about 1.5 feet. After applying the 80 feet of refraction and over 300 feet of curvature, I happen to be almost exact, but that radio antenna was at my horizontal. So horizontal does not mean the same as a constant elevation.
You call it a vertical angle because it's in the vertical plane.
Correct.
Are all of the verticals in that vertical plane perpendicular to the baseline?
No. Only at the instrument is vertical and horizontal perpendicular. As you head out any distance whatsoever, then perpendicular to my horizontal is not vertical at that location.
So the perpendicular relationship of horizontal and vertical wouldn't be maintained within your vertical plane that you're measuring the angle in.
Well, can you see the chat?
Which one? Open chat. I'm looking at it at the minute.
Okay. Stand by. Yeah, this is what my measurements return. And the relationship of perpendicular to horizontal and vertical, as by my measurements.
Tilt of the vertical. Equipotential angle of adjustment. So there, you documented it.
I don't know what you made up equipotential angle of adjustment. So yes, you did, because I can't find any reference to it other than your own.
You've labelled it there. It's the angle of the adjustment for the orientation of horizontal and vertical over distance. You've labelled it.
Okay, so we can clearly see that vertical lines are only perpendicular to a horizontal at the instrument. Vertical lines to all other locations on that horizontal are not perpendicular to that horizontal. I'm glad we agree. Welcome to the globe.
Right, yeah, tilted vertical, equipotential angle of adjustment. We've done this all. I don't understand why you're arguing. Well done, Larry. Like there,
yeah,
it's
so
within
you
that
can see,
one picture.
yeah, there you can,
I keep that on screen.
Yeah, so there
you
can clearly see.
Sign it.
There you can clearly see the arc of the constant elevation.
The deviance of the orientation from a point.
Welcome to the globe.
Dogmatic globe. Oh yeah, 'tis globe.
No, the one I measured. The one I measured, dude.
Yeah.
Measurement.
You go down in the history books with this.
Oh no, I happen to agree with far too many people to go down in the history book as anything special.
I call that the rumpus pole, the unit of measurement between horizontal and level. I think that's what it is, isn't it?
No, well, we just call it vertical on the globe, just like the Ordnance Survey UK says.
I bet you went mad at Mick West when he dropped the like perpendicular from what he called the surface level. He called that horizontal a surface level and did a perpendicular from that. It's like, you know, he's got completely the opposite way around from you, hasn't he? I hope you put him right.
So
he's still not sorted that, Larry. Why don't you?
Well, okay. I just was asking you.
Right?
Okay. As this started out, I was just asking you if I put up my auto level and theodolite and see a radio tower quite nearly at my horizontal, and it's 400 feet higher, then how is horizontal level?
How did you measure the 400 feet higher? With the auto
by getting
level
right
from
next
28 foot away.
No, by getting right next to the tower and measuring the vertical angle to the tower. So I started with 1 mile away, and then I progressed to 28 miles away.
Okay. So how do you know that the elevation at that other distance? How did you measure that? The difference in elevation, or did you just measure the distance in the height of the tower from one location and then look at it from 28 miles away?
I got the elevations from published documentation at the base of the tower, determined the elevation of the tower. Then I went 28 miles away and repeated that exercise, and I got the same elevation both times for the tower.
Would that be the tower then at the distance then at number 9?
No. This is a subset of the measurements because that is not 28 miles.
All right. How far is that then? Oh, just a kilometer.
28 miles in kilometers. Okay. It's about.
No. I mean, in between those marks, 1, 2, 3.
Oh, yeah, those are 1 kilometer. Those are 1 kilometer.
Which one's the kilometer? In between the black lines that are along the horizontal, or along the one of 0 elevation?
Along the 0 elevation, yes.
Okay. You should have put that 1 kilometer down there at the bottom, then, really, shouldn't you? In between the green ones. It's a bit,
I wasn't. I didn't create this for you. I created it for myself, and I thought I'd share. Maybe I should have labeled it more, but I'm sure many other people in the chat could have read that and figured everything out.
9 kilometers then.
And nine marks. That would be 1 kilometer per mark. Yeah, I should have labeled it.
And a tilt of equipotential angle of 291 arc seconds, is it?
Yeah. So what you're calling equipotential angle of adjustment,
we just 6.3.
Yeah. So what you're calling equipotential angle of adjustment, a completely Bev only term, is apparently.
Did George not ever call you that? He calls the surface the equipotential surface, right? So this is the angle of the adjustment. Like, you can see that the adjustment of the vertical is within that angle. That George taught us this. I thought, like, maybe it's the way that we put the words together, but like George formulated it. He explained it there. You perfectly drawn it. Exactly as George explained it. It's the adjustment angle of the orientation to equate for the equipotential surface.
Well, good, because the equipotential surface is the 39 60-mile radius of the Earth, and the curvature must be applied in all our measurements to get the proper elevations when using vertical angles. Welcome to the globe.
Everybody knows this globe, yeah?
Everybody knows it's a globe. Thank you very much. That's all I had. That was my question.
Yeah, sign it and move that 1 kilometer thing there, because that's a bit confusing.
comes back to the point, 28 miles away. The radio tower is at my horizontal and 400 feet higher. That was my point.
Yeah. You should be praised much more. You're the only one that's managed to stick it out. Where did the others go? What happened? Jesse and Jeff, where did they go? Sorry to hear about George. Somebody saying that I'm trying to grift for money. Why do you have such bitter people here, Demon?
You know, I hand select individuals to be here, and it's based on how bitter they are. The more bitter, the faster I add them to the channel.
Yeah, and if you're
That's
a complete,
true.
utter fucking asshole like Sean G, for some reason you get mod rights as well.
That's true. There's like a big waiting line of all the bitter people trying to get in, but they still need to go through the vetting process.
Yeah.
Yeah, that's me. On the level, .live, the equipotential angle of adjustment, EAOA.
Yeah, so, but it goes back to the point. It goes back to the point that if I extend a horizontal from one mountain ridge to the radio tower being 400 feet higher is still at my horizontal.
I thought, I was hoping that Ranty was going to go and do the challenge, and he never managed to do it. So in the end, I was the one that was proved true, I guess. Ranty
Where
wouldn't
do you
go up.
think
I was
that-
hoping to get a statue of it. It could have started off, you know, like 10th Man started that trend off where everybody was buying sextants. Well, if Ranty had gone up there, if you get on it, Larry, you might get like a big deal on getting auto levels sold, taking them up the mountains.
Well, an auto level, the auto level was just to compare to the theodolites 90 degree, and they agreed completely. But the tower was not precisely at that, so I had to measure the angle, and then I determined the distance being 147,000 feet. And so, yeah, I did the calculation, and the elevation of the tower, I was able to measure that to within 1 foot, or maybe 1.5 foot, maybe.
Did you use Euclidean triangles?
Only after applying curvature of the Earth. So, welcome to Globe.
Did you use Euclidean triangles?
Yes, I did.
Trigonometry?
Yes, I did, because it's a vertical plane, so it is very simple math.
So I have to read out what Bev is claiming is what their thing of EAOA, the equipotential angle of adjustment.
Yeah, go on.
Never measured, only reverse imagical measured from predetermined values generated by predictions from the great model-making shadow giants of the past, present, and future. This uses the elusive calculated non-measurement are beyond imagination. Read to learn more. What?
Is that a quote from George? Is that a quote from George? Is that what George told you?
Obviously not.
Yeah. You don't disagree with it, do you?
Entirely.
That's word salad. That's word salad.
People
it
have
means
often
nothing.
said that, yeah, you can't really.
It means literally nothing.
I know.
Okay, is that a citation? Is that a citation from any source other than your own?
It's not. I can tell you from looking at it. It's not
You've got the
cited.
angle there. It's in the picture.
It's not cited.
Well, I wonder why that is.
I don't know. Why don't you cite your sources?
Well, mainly because it wasn't there to be cited, right? But Larry's got the picture for us, right? Larry's definitely got that picture. And that is the explanation of the equipotential angle of adjustment. Now, if you can't find any cited source for it, then that must mean that I'm the person that named it.
Well,
it might never have had a name, like the Rumpus pole, right? The separation of vertical and horizontal over distance that goes along with the equipotential angle of adjustment.
Okay, I put up.
Here's the deal, Bev. Here's the deal. You didn't cite it. You literally just said you didn't cite it basically because you made it up.
Yeah, there was no...
That's what you just said.
Yeah, it's not there. You can go and have a look. That's the only cited source of the equipotential angle of adjustment, other than Larry's picture. And Flat Earth Dogma has done a couple of things with... Blue Marble's done it as well. Zenith angles require the equipotential angle of adjustment.
Yeah.
Not once did I ever use that term.
You made up a term. Yep, you made up a term. You didn't provide a citation for that term that you made up.
What do you call it?
Now it's so vague. Hang
on.
on.
What do you call it, Larry?
Now it's so.
Hold on,
and
Dad. Hold on, you gotta let him finish.
Now it's such a vague term with word salad for a definition that you can apply it to literally anything. So your claims that it applies to something that your claims that it applies to what Shoebill has posted and what Blue Marble has posted
of an orientation over distance.
Give him. Hold on, Bev. Give him another 20 seconds. Let him get the whole thought out.
Yeah, your claims now that this random word salad that you've made up, that you have admitted that you made up, apply to Shoebill and apply to Blue Marble and their observations and their measurements is just a claim with zero evidence and is therefore dismissed.
No, it's the tilt of the vertical. Dude, it's there in picture form. The angular adjustment or the orientation over distance.
Never measured, only reversed and magical measured from predetermined values generated by predictions from great model making shadow giants of the past, present, and
Did he
future.
measure it?
Yes, I did measure it.
Oh, there you go. So we can get a cited source. Larry has confirmed a measurement of the equipotential angle of adjustment, the tilt of a vertical.
Okay. Oh, let's just rename that to the central angle at the center of the Earth to sea level.
Plus, your definition says that it can't be measured. So if you're claiming that it's measured, then you've already proven your own definition
Larry's
wrong.
just called it the central angle. Did you measure the central angle, Larry?
Yes, okay. I did.
Nice.
And I put up an additional graphic to further explain, highlight what I was explaining about the difference between horizontal and a constant elevation. I had to look down to a tower that was higher than me.
Yeah, so you directly measured the equipotential angle of adjustment.
I don't use that term because I've never heard that term outside of your invention.
Yeah, you watch it. It'll catch on.
No, I doubt it.
Wrong.
I doubt it. I go with the Ordnance Survey UK for technical things.
Mm-hmm.
Yep. So
I go with horizontal and vertical being perpendicular.
Bev, your definition says that it can't be measured, and you've made several claims now that it has been measured. So which is it? Is it measured or is it
not say
incapable of being
imagicalcular
measured?
Yeah,
so that would be not a direct measurement because based on the word that you made up.
Imagicalcular measured.
Because based on the word that you made up, it is not an actual measurement.
Imagicalcular measured as well, but it's still measured if you imagicalcular measure it, isn't it?
Sure. So great, but you are both claiming that it cannot be measured and that Shoebill measured it. So which is it?
Well, Larry's the one that's claiming that he's measured it. I've just seen a picture.
No, Larry does not accept that term that you've given him.
What, the last, like the white rhino with the globe surveyors?
Larry does not accept that term that you've given him. As a surveyor, he's never heard that term before. So unless you give him a citation that is not from you of that word, then he's not going to accept it.
You made it up. You made it up because I can find no reference to that EAOA.
There is no measure of tilt of a vertical. That's fucking ridiculous.
No, I did measure the tilt of the
There you
vertical.
go. So that's the equipotential angle of adjustment then. Because there's no other reference because you don't tilt verticals. There's no such thing.
Then right. Okay. And how does that relate to your water level?
Water level is a tool that establishes a horizontal plane of reference. Where would the horizontal plane fit in your picture?
How do 2 points form a plane, Biv?
Oh, a horizontal plane of reference, water level.
How do 2 points form that plane?
Well, you can. Have you never? Are you an engineer, Blue?
Yes, I am. How do you get a plane from 2 points?
You can get a plane from 1 point, can't you?
Bev, 2 points do not define a plane.
But as far as elevation is concerned, 1 point would define the plane.
Are you claiming that 2 points define a plane? Yes or no?
You just use 2 point, as well as the actual level, but in order to establish a 2 peg test. But with the water level, you just need the 2 points.
Those 2 points define what, Bev? A plane
horizontal
or a line?
plane of reference if it's a water level.
Really?
Mm-hmm.
No. Bev, please draw me a square using 2 dots.
What?
And you can connect those dots.
Please
draw me a square on a...
Water levels do not draw squares.
What you're saying is with 2 points you could draw a square on a piece of paper.
I say with a water level you can establish a plane of reference. A horizontal plane of reference. That's what I'm saying.
I say you can't take 2 points and define a plane with only 2 points, Bill.
Okay.
You need a third point.
To agree with what he's saying, a water level describes a 3-vector system, which is more than 2 points. Well, so he debunks himself.
You can move one of the points, right? Wherever you want, can't you?
Bev,
now you don't have 2 points.
Bev, a level.
You have 2 points. You have one at each end of a water level.
You just said you can move one.
Yeah,
now you've got a third point.
No, it's the same point. You're just moving it to establish a horizontal plane of reference.
Oh, so you can move it and it's still the same point. Really?
The water level, yeah. It's got 2 ends, Blue.
Yeah, I know it does.
Yeah.
I know it does. You set your
water level up. And establish a horizontal plane.
You connect the 2 ends of the water level. What does that form? Does that form a line or a plane?
This is like a straight line with a 90-degree angle a couple of years ago.
So the way to think about this is if you have a sphere, if you have 2 spheres in your hands, which are formless, they have no detail on them, right? And you hold them, you have nothing to describe where this plane is.
Without form.
Reference. Yeah, so if you've got think a tennis ball, but with no detail on it. It's a super, just completely white cue ball, for example, yeah? You can have 2 points in your hands, but where is that plane? Is it tilted towards you, away from you, sideways? No, you need something on that ball to describe it. So if we draw dots on it at the horizontal vertical angle, so top, bottom, left, right, forwards, backs, you then have something to orientate those balls. That's what your spirit level is doing. But that is using more than 3 points of description. That's your problem, Bev, is you're using a spirit level and saying it's a single point. It's not. It's a description of rotation, yaw, and pitch.
I think we made it clear that we said water level, right? Not spirit level. We were saying water level.
What's the difference to you? They both work on water. A spirit level has water in it, genius.
Spirit, genius.
Which works the same as water level. It has a bubble in it surrounded by liquid.
It doesn't work the same as a water level. Somebody tell genius here.
Yeah, let's try to not use calling out names because then it just devolves into a shit show. No matter how smart you both are, you're both fucking
I mean,
geniuses. Continue, please.
So stupid. It's liquid.
So
So who cares?
So while I've been listening to whatever this is, I've also been trying to find more sources for the equipotential angle of adjustment, and surprise, surprise, there aren't any. Everything just comes back to Bev's website, and that's really strange, Bev.
Okay, so what do you find about the tilt of the vertical then?
What do I find? I wasn't looking up the tilt of the vertical, was I? I was looking up your term.
Okay. Yeah, the equipotential
That you claim
angle,
is
that's the
that you
tilt
claim
of the
is a term.
vertical. Yes, the amount of tilt of the orientation over distance. What do you find out about that anywhere? Because I mean, we've only just started the study. Larry's the main man. He's the guy.
Curvature.
I'm thankful to be able to talk to Larry. He's such, he's the man.
Yeah, but the term that you keep giving people is a term that you made up, which to everyone else on Earth is just confusing nonsense.
Yeah, I know, because nobody's ever heard of it before.
Yeah, and calcumeasure.
People aren't aware of the tilt of the vertical.
How do we use it? What's the utility of that?
Okay.
She gets let's say that with one person. Is Watchmaker, you want to pass the torch yet, or did you have a final point you're trying to make?
No, go ahead.
Everyone is aware of the tilt of the vertical, and because it's the globe, and the radius of the Earth is easily measured and easily incorporated to determine elevations of distance points by a vertical angle measurement and the curvature correction of 8 inches miles squared as a plus and 1/10 of a mile, 1/10 of a foot per mile squared as a minus for refraction. Yes, time-honored science. Welcome to the globe.
Sorry, I'm just making me tea. Tis globe.
Hey, Bev, you ever heard of concave Earth?
How valuable it is to use math to prescribe what the Earth is. It sounds pretty dumb.
Well, did we win? Is it over?
Was that a win-lose situation? I don't think so.
It has to be. It has to be. There's only enough room for one winner here, Bev.
Well, I think we all agree that the equipotential angle of adjustment, nobody else has named it, so we'll call it that. Yeah, but it has been measured by Larry, or claimed to be measured by Larry.
No, Larry never claimed that.
Yeah.
Don't gaslight people.
Well, Larry claimed to have measured the tilt of the vertical then, right? The adjustment
that's
of
not
the
what
orientation over
what do you mean with that?
Yeah,
That's not the term you made up.
What is that called for the thing that he's got the name for that you measured? What would you call it?
Well, I'd say that I'd use the rumpus pole, the distance measurement, the separation between level and horizontal.
I'm just
Exactly.
curious because you agree that
You
Larry
won't find
measured
that
it.
mentioned
I'm just
anywhere
wondering
else
what
other than
Larry
me
would call
either.
it. Yeah.
Also,
I would
a representation of the
just
angle
think
of
that
adjustment, the equipotential angle of adjustment, just the opposite side angle.
I would think that something, a term like tilt of the vertical would be some measure of deviation from your zenith.
No,
Yeah,
it's the
that's
tilt of the
that's what
actual
that's why I asked
orientation of vertical, isn't it? The equipotential angle.
in
Adjustment.
reference to what?
Over distance, so it's in reference to the original point.
Yeah, so reciprocal zenith angles, you can just say that, and not equipotential angle of adjustment.
You get a bit tricky there because then the perpendicular at the other end isn't perpendicular to the horizontal.
Yeah, because we live in reality.
In relation to each other point, they're not perpendicular to the horizontal, and saying that vertical isn't perpendicular to horizontal sounds fucking mental. That's why we use these terms.
Perpendicular to the horizontal at that point, Biff. It is perpendicular at that point.
Yeah, which I was talking about earlier. The 2D surface that you imagine has all horizontal points, like you've just said. At that point, that's where the horizontal is. And every point on the two-dimensional surface of a mountain, let's say, would have that horizontal point. So all points on a two-dimensional surface of the globe, everywhere, are horizontal, right, Blue?
All zeniths are normal to the ellipsoid at that zenith.
And that would be where the horizontal is horizontal.
And you have a horizontal at that point.
But you have one in the middle as well at the two of a water level, don't you?
And if you move, you have another point and a different zenith and a different horizontal, Bev.
But all points would be horizontal, right? Individually.
No, there's an each.
Tis globe.
You're just playing word games.
It has to be.
Yeah, there's an infinite number of horizontals and an infinite number of verticals across the globe.
But your two-dimensional surface, like Stingray said, doesn't have vertical.
Yes, it does.
Oh, wow. Your two-dimensional surface also has vertical. I've got a clip of Nathan Oakley saying XYZ is a plane.
Oh, don't play him. Draw a circle, draw a line from the center out. You have an infinite number of those lines around the circumference, and thus an infinite number of horizontals and verticals for each line.
Of a radius.
Well, yeah, don't gishgalap. I'm describing a line to the circumference. That line describes a vertical. There is a horizontal for that line, and there's an infinite number of those lines. That's why you've got that deflection.
Okay.
Because you're on a globe.
Two-dimensional circle that you're doing it on is a plane.
Yeah, now extrapolate it out to 3D, and maybe you can understand it.
I've got a question
2D, 3D.
This relates directly to this. Do you think it's possible to use geometry to predict expectations of what we might see in reality?
Oh, Stingray.
Like trigonometry. You can predict
trigonometry would be
the length of the side of the
way to do that. But if you make it a little bit more complex and bring more complex geometries into it, more complex motions, do you think it's possible, given a hypothesis of what something might be, to create a geometric representation and then to predict something in reality, to see how well that model matches, not whether it's true, how well it matches?
Right, and what, are you going to test the Euclidean model?
I'm going to test 3D space and geometries. Is that possible?
Euclidean, I would say. Is that what you would be testing?
Do you think that's possible?
How closely reality follows the Euclidean mathematical model, would you call it?
No.
Geometric model.
Logical
model.
Yes. Yeah, given a hypothesis, let's say the Earth is flat with topology, or the Earth is a sphere with topology. Let's make a prediction. Do you think that's possible?
I could definitely make a couple of modus tollens for the flat Earth and the globe Earth. Yeah.
Go for it. You do it without definition conflict or word conflict,
keeping
and do
the
it with
law of
something
identity intact.
Observe. Go for it. Let's see. What would you have? What opposing statements would you say about either or? No, that's way too many. Pick one. Okay, I suppose all of those might be valid. Sorry, have I convinced anybody else that Bev's actually talking yet?
I honestly thought he was posting it to chat or streaming the list.
I was going to do it, but my next sentence, you'd have heard a smile in my voice, so I knew I was going to fail at that point.
He could be making tea, but then again, last time he was making tea, he talked.
I'm just wondering, like, I'm not a math guy, so every time he says Euclidean blah 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 blah, like I just looked it up, and all that seems to be is just rules about circles.
I think it's just Bev's latest little word salad game.
I mean, he's been doing it for years. He just takes Euclid's postulates, applies them to reality without no backing, and then says, "Yeah, this math prescribes what reality does." So even if you showed him the Earth as a sphere, he would say it's not a sphere because level is horizontal.
Yeah, which is dumb.
Well, for instance, like like one rule seems to be the line drawn from the center of a circle perpendicular to a chord bisects the chord. Wouldn't that be the same general thing with any section of a sphere? Like you take a section of a sphere, you do a chord like a chord measurement, and then you draw to the center of that section that you've cut out, and it's still going to do this.
You back for making your tea, Beverly?
But it's just.
Who's that?
I'm just making the point that you keep saying Euclidean geometry, but it just seems.
Yeah, hold on. I said earlier, please stop the name calling. Don't call him Beverly. Not cool.
Okay.
Yeah, you will get instantly timed out for it. Just so you know.
Yeah, these Euclidean geometry rules. I'm not seeing anything that would like say that the Earth isn't a sphere.
No, you can have Euclidean 3D space. So there you go. Just 3D space.
Yeah, Euclidean 3D space. Everybody understands what we're talking about when we do go into discussion.
Yeah. So if I create a Euclidean 3D space, let's call it a geosphere. So nothing with relationship chords. It's just made of equal triangles of distribution over a sphere. It is geometry and it is static. There's no mathematics. It just exists as a definition.
Euclidean triangles.
Say again?
Euclidean triangles.
Yeah, you can call them whatever you want. Just call them triangles. Now, if I place an observer on that and they are orientated to a normal of that surface, then I rotate the surface, given the fact that we'll tilt it a little bit at like 23.5 degrees or something. Do you think I'll be able to get decent predictions about reality out of that?
I haven't got a clue. You could do whatever you wanted. Yeah. You're a model maker, aren't you? You've probably done this.
Oh, I have.
Yeah, there you go. So, yeah, you probably can then. Yeah.
All right. And do you think that gives credence to how, well, do you think it gives credence to the fact that it can describe what happens in reality from multiple facets with just a single input of rotation?
Well, I don't know. Would you be using horizontal points or horizontal lines and planes?
I'm using a sphere and I can use anything that I want.
That's not very precise, is it?
Well, I don't know how you mean I'd use a plane on a sphere, but okay, I could stick a plane on a sphere that just represents a garden that's approximately a plane, or a street that's approximately a plane, and say, hey, if this was on a sphere and it was indeed flat and we were all rotating in 3D space
Spheres
on
aren't
a
flat, though, are they?
tilted,
Unless you consider them 2D, I guess.
on a tilted sphere, does this represent reality, as in what the sun's doing, what the moon's doing, what the terminate line is doing, things like that?
Do you
That'd be pretty
consider
cool
the
to do
surface
that.
of said sphere to be 2D?
I'm not bothered about the surface at the moment. I've got
Well,
no
that's what
further
we're
stuff
talking
off.
about, really, because that's the conceptual part that I can't really get over. There's
All right,
people
forget
here. I know
forget
that
the
you're
2D.
talking for them, but that was the question: was why do you consider all mountains as being 2D? The surface of everything was the plane.
I don't consider all mountains to be 2D.
Yeah, it wasn't
They
you
have
that made the
volume.
claim, Stingray. It's no, it's all right.
No, it isn't. No, it isn't. A mountain has volume. The surface, people were arguing about a surface.
Mm-hmm.
On a surface, I have texture coordinates. Those texture coordinates, actually, I can have 3D, what you call brick maps or spatial 3D maps, but fuck them off to one side. Textures have two coordinates, U and V, predominantly on a surface, and they're tied at a vertex level and interpolated between. That is just a two surface. The surface itself, the tangency of it and the realization of it when you look at it in the 3D space, is a 3D object.
You know, I was just thinking, so think about it this way, because you do graphics and video game stuff. Imagine you had like, you know, the earth, and you wanted to put a texture on the earth, and you wanted it to look like mountains and water and ground. That skin that you would put on that, would it have a volume or would it be 2D?
No, so there's, okay, so from a fundamental sense, you have what you call height field maps, which actually are 2D dimension. Well, sorry, they're 2D defined, one-dimensional, believe it or not. So in other words, I have a grid, and I say, and most large terrain systems in the past 10 years have used this, where you just define a grid size. Let's call it 10 meters by 10 meters in world unit scale. But then you forget, you don't need to define anything else. You then just come up with a single coordinate, the elevation. And that's the only variance along that. So now you only have to store one elevation, and the index order or indices of that elevation maps out to the height field map, hence why it's called a height field, which creates terrain. Now, if I was going to do that on a sphere in kind of like rasterization and non-real time, or maybe even real time in this day and age, I'd use multiple maps, but they would always be 2D maps. They might have more data. So let's say a height map might have a lot more data than your normal map, because I might need better ranges. You know, ranges, it wouldn't just be color, it'd be a single, you know, it'd be a grayscale, but that grayscale would have a lot more fidelity than anything else if I needed to do it on a large terrain system. So it's still a 2D map, but it's applied to the surface, and then at render, you can real-time tessellate it to then, so that that tessellation gets moved either up or down based on that 2D map. But the referencing system for that to happen is still 2D on that surface. I hope that explained it, but fuck knows.
I just want to know why we're suddenly.
It's classed as a polygon.
Why are we talking about
surface?
Why are we talking about the little dangly things that go on top of mortarboards?
The little dangly things.
Yeah, tassels. You said tassellation. Why are we talking about those?
Yeah. Nice.
I found an image of the height map for Breath of the Wild, I believe, for anyone who's interested in chat. The grayscale basically describes how high or low that bit of terrain will be.
Now, just to augment this as well, you can have vector maps as well for that displacement. That procedural displacement, which means you can have a map that consists of multiple colors, and those colors represent a direction. But that's still a 2D map applied to a 3D surface, where that 3D surface after tessellation is going to get either parallax drawn at rasterization or geometry moved at tessellation to that place. But it's still a 2D referencing system. But anyway, Bev, yeah, I did an interesting thing outside. I got time lapse out of one of my cameras that looks down onto the road, and looked at a shadow of a lamppost. And then I put my house on a globe, put the lamppost on the globe where my house is at the angle that it is, turned the globe axial tilt to what it would be like, in November, mid-November, and then rotated the globe, and the predictions matched the reality outside my window pretty decently. Within a few inches, I would imagine.
Modern day Aristophanes.
Well, Euclid said that the Earth is flat, so obviously
Street
you're wrong.
lamps. Did he?
I think he actually did, because he said that the sun goes below the.
I think,
sun
have you
goes
been
below the
watching that?
surface
That
of
was
the Earth.
probably on Nathan Oakley's stream, wasn't it? Is that where you're taking that source from?
No, I read it from Euclid himself. He says that the sun and the stars go below the surface of the Earth. He was a bit of a flirt.
Hey, Bev, I got a question.
These are obsessed with flirts. Yeah, go on. Is that Larry?
Yeah. In the first diagram I gave you, if you were to set up a water level 9 kilometers long, and the first water column is right even with the instrument, do you think the tops of the water columns would follow the horizontal or follow that arc of constant elevation?
Yeah, water level is a tool for establishing a horizontal plane of reference.
That wasn't the question.
Yeah, follow the horizontal. Yeah, it's a tool for establishing a horizontal. There would be no slope. There will be no measured change on the vertical at either end. The equal altitude, always.
Okay. To be clear, I'm talking about the water columns, and you're saying the water columns the tops of all water columns would be along the horizontal and not along the line of constant elevation. Is that what you're telling me?
Yeah, the horizontal, no slope.
Okay, the arc of constant elevation, a constant elevation is no slope.
The horizontal. You're not saying that the horizontal slopes, are you?
Yes, I am.
Oh, okay. Well, I don't think horizontal slope, Larry.
Well, there you'd be wrong when you get out there more than a few hundred feet, because a constant elevation, by definition, is no slope. So a constant elevation is where the tops of all the water columns would be, not along the horizontal.
Yo, Larry, thanks for the readings.
If you would actually measure your water level that you're so proud of, you would find that out.
Bev, would you agree that two horizontal lines can be parallel and perpendicular at the same time? Do you agree with that?
What, both parallel and perpendicular?
Yeah, it's like x-axis and y-axis, line on both axes. Those would be perpendicular, but both would be horizontal, right?
You'd add them together to have the XY plane.
No, but two horizontal lines can be perpendicular, right?
The plane would be horizontal.
No, the line. Yeah, but the lines would also be horizontal because they lie on a plane.
Betty's cross. Beddy's cross. They both lie within the same plane.
Yeah, so they are parallel then, right?
What? How could they be parallel with they're lying within the same plane? Do you know what parallel is?
Sure. So you're saying that two horizontal lines are not parallel?
No, you're saying that perpendiculars would be parallel. Why are you saying that?
Well, I'm
Sounds
asking you, if I have a line on x-axis and a line on y-axis, are those perpendicular or parallel?
They
There's
would
a
be
90
both
degree angle
within
between
the
those.
same plane, right? So you'd be
Sure, but
talking about
that's
the
not what I'm
plane,
asking. So
the
only
two
the plane. So we can't talk about
dimensions
lines anymore.
of the plane.
So we can't talk about lines now.
You can talk about lines as much as you want, yeah.
Sure. So is a line, a vertical line and a horizontal line, are those two lines perpendicular?
A vertical and horizontal are perpendicular, yes.
Okay. What about a horizontal and a horizontal line?
It depends, doesn't it? Where have you got these horizontal lines? Because if they're just lines on a plane, they're just lines on a plane. The plane's horizontal.
Then the horizontal.
If the plane's horizontal,
when you said
then the plane's horizontal. All lines would be contained within the horizontal plane. Every line.
Well, then all the horizontal lines, if you have a horizontal line and a vertical line, those both are on a vertical plane, right?
Sorry? If you have the ZY plane or the ZX plane, let's say. Yeah, like a whiteboard.
So those would okay.
Yeah.
Yeah.
So you could represent both a vertical and a horizontal on a vertical plane, couldn't you?
Yeah, and then you can't anymore say that they are perpendicular because they're on the same plane, right?
Well, they would be within the vertical plane, and they would be perpendicular. Yeah. And all of the lines, perpendicular to the horizontal would be parallel, right? At least within that board.
You just said that the horizontal lines are not perpendicular because they're on the same plane. Are you saying that the vertical lines, or the vertical and the horizontal, are on the vertical plane, but they are still perpendicular?
They are perpendicular. Vertical and horizontal are perpendicular, yes.
Sure, and two horizontal lines that have a 90-degree angle between them are also perpendicular, correct?
Yes. Yes.
Okay, there you go. Yep, so horizontal and horizontal are perpendicular.
Well, the plane isn't perpendicular, is it?
That's why I'm talking about the lines.
Okay.
Like the LIGO arms.
Yeah, but
are LIGO arms horizontal?
So they're both on a horizontal plane, are they?
So are they parallel?
Absolutely not. They're perpendicular to each other. But they
then
on a horizontal plane, are they?
Sure, but then when you're saying that horizontals are parallel, then you're wrong because you just said they aren't.
Yeah, all horizontal planes.
So not lines then.
Yeah, lines.
Yeah, lines. Yeah, lines. Let's say the arms of LIGO, they have a 90-degree angle between them. They're both horizontal, correct?
All on a vertical plane, all horizontal lines would be parallel, right? Because
on
the
vertical plane.
Representation of it is on the vertical plane. Yeah, you're seeing horizontal lines on the vertical plane.
Sure.
Okay, well then they would be parallel,
would they be
right?
perpendicular to vertical? They would be perpendicular to the vertical.
How many vertical planes? How many vertical lines can you draw on a horizontal plane?
As many as you want. Just draw them on the plane.
On the horizontal plane?
Yeah. Why not?
Well, because it's a horizontal
I think that there's a limit. Yeah.
Okay. So you can draw horizontal and vertical lines on a vertical plane, but you can't really draw vertical lines on a horizontal plane, can you?
Well, you can draw them, but they'll leave the plane because you go to 3 dimensions. Yes.
Yeah, because horizontal requires 2 dimensions. The plane. And you can
So
reference
does
the other
vertical.
dimension to that, can't you?
So does vertical. You
Elevation
need to
changes.
for that too.
Yeah.
No, I'm not
Measure
talking about the Earth.
elevation
I'm talking
changes
about
a
the
reference to
math.
that horizontal plane.
Talking about math.
Yeah, I'm talking about the relationship of that math, geometry, to reality, practical geometry.
Oh, you do? Oh, what defines vertical on the Earth?
What defines vertical in plumb bob?
Yeah. Yeah. How does it do that? How do you know that it's vertical?
Because it's a plumb bob. That's what plumb bobs do.
That's
They
circular. You're
show
saying that
you what a
the plumb bob is
vertical
vertical
is.
because vertical is plumb bob.
Yeah, it's an element.
What? An element?
Yes, vertical. Same as
do you mean?
horizontal. It just is. There's no words for how. They just are. They're elemental.
And then you're not connecting it to reality then.
Yes, I am correcting it to nature. They're reality. They are the fundamentals.
The number 47 could be called elemental, but you still need to explain it.
Yeah.
Couldn't be. One
Yeah, I
would
can
be
say vertical's
elemental, wouldn't
diverse.
it?
That's
Because
just elemental.
47 is built upon the unit, the one.
Yeah, so please
The plumb
describe
bob
the
is built out of
unit.
material.
Plumb bob.
We can't define one. You can't define straight for the same reasons you can't define horizontal or vertical. They are elements.
But
First
you can still
principles.
describe them.
They're givens, self-evident.
So how did we figure out that plumb bob is vertical? Like, where's the connection?
It's
Who
a
came up with it? This is
perpendicle.
plumb bob.
Anything
This is
hanging
vertical.
down by a straight line. Perpendical.
Hold on,
Call it
wanna,
plumb. True.
I'm going to correct Bev for a second. Can't describe one, right? Okay, I will. Have an empty hand and pick up a rock. That is what one is. I'm going to describe straight line, right?
The hand or the rock.
Put the rock in my hand is a description of one.
Okay.
Pick up
Just
another
the
rock,
rock
that's a
in the
description
hand?
of 2. Pick
With
up
the
another
same
rock,
hand?
that's a description of 3. I'm now going to describe
Different
straight. Put down 2 rocks and go from one to the other in no deviation in the quickest route. That is straight.
Okay. Well, what's the rock without the hand?
That's 0. It's 1 less than 1.
So you're having your hand and the rock being one.
The concept of picking up a rock describes what 1 is in the
So
quantity
one's
of
a
rocks.
concept now of
It's
handling
elemental,
rocks.
you said. Yes.
Yeah, I mean,
elemental.
you're defining it. That's okay. Is everybody all right with this? The
Yeah,
definition
Yeah, I
of
same
mean,
one?
as
we are using math to describe reality, not prescribe. Yes.
yeah. So now, please describe the elemental of plumb, like I have described the elemental of straight and 1.
You haven't described the elemental of straight and one.
Find me one person in this chat that disagrees.
Well,
that isn't you.
I just want to point out that I disagree slightly. It should have been, direct path rather than shortest, because something could have been in between.
Damn it!
Oh no, yeah, no, sorry, it should have been shortest, not the quickest. You said quickest.
I was trying not to say straight to describe straight, and I fumbled.
The shortest distance between 2 points.
Yeah, and if it's on a surface, then it can.
Then it can
be
deviate
on different kind of shapes. Yes.
See, this is why we do things like this in consensus, Bev, because then we come to good explanations.
If we can have a surface, then we can have it not being the shortest distance between 2 points. Which sounds contradictory, right? You put in a condition there to say not that. Really weird, but I mean...
I thought we were giving a definition to plumb, Bev. I've done my part, you do your part.
Yeah.
Come on, don't get scallop. Stay on topic. Don't get distracted by the squirrels.
What if I say that trees always grow vertical, then I find a tree that is not straight to the other tree?
Yes.
Because trees are quite elemental. I mean, obviously the model afflicted use gravity as vertical because that's demonstrable.
Did they try to grow plants on the ISS? I can't remember. I assume they would have tried that and see
Brenda
how
called
they acted.
trees elemental as well, dirt and rocks elements.
Yeah, do you believe that the ISS is there, Bev? Is that a real thing in your reality? The ISS?
Depends if they show the curve.
I'm just curious because that is like, we've seen it here. Tactical French Cat could show it. Seafoam's done it live. So, I mean, you got a telescope. You can actually look at the definition of it as it's going overhead. And, from the ISS, it does appear to still curvature of the Earth. Take that as a no.
Guess it's tea time again.
Yeah, when MC Toon was in here last night, I wanted to ask him. Wanted to bring some of the other topics you were talking about. I couldn't think of any.
And then right after he left, we talked about him for hours. Talked about topics for hours.
Yeah.
I mean, did you hear what the Anthony Riley said about the dome?
No, what did he say?
He said it was the flexing of the dome, like gravity is. Was it gravity? I think it was gravity. It's flexing of the dome in some kind of a stream. Don't remember. It's on FTF's latest video. It's fucking weird. He says that gravity is just a bit of a refraction.
Wait, what? Gravity is refraction?
Yeah, just a bit of refraction, because obviously gravity affects light, so it's just refraction.
Gravity is. No, that's
So,
Sleeping Warrior.
anyone who's interested, we're doing the Friday dissecting flat Earth. Dissecting flat Earth Friday at 8:15 Central. So stop by the Discord if you want to be on it. I can shoot you a link. We got 10 spots open.
Forget that one. There's a much better event happening on Sunday.
Yeah. Oh, and there's is it defined now? It's actually, you guys get a time?
Well, no, you got to do the time because you're the one hosting it, dumbass. God damn it, dude. Do I have to teach you how this works?
Jesus Christ. Just remind me to unmute you.
Is it the Babs interview on? Is it the Babs interview on Sunday?
It's gonna be Brian versus Sean G on a flat Earth debate.
I'll put
Brian.
Yeah, Brian Leakey.
Oh,
yeah,
then 4 p.m. Central.
Yeah, and Demonstrate did the interview with Space Pope. I'm putting the link in the chat right now if you want to watch it.
Oh, thanks.
If he jumps to 5 minutes in, that's when I unmute him.
Yeah, he doesn't. Demonstrate doesn't like me and Space Pope, so he likes to just mute us for the very beginning to be an asshole. I don't know why. Matter of fact, I think I was more than 5 minutes, and he still refuses to redo the interview. It's kind of odd.
Hey,
Because his name, Moleman, his name is Bab. I know him as Babs, and his new name is
it's
Space
a funny
Pope, so I
Space
mix them up.
Pope.
Yeah, I mix them up sometimes. What makes it even worse? Because I know it's fun. What makes it worse is I even know his name, so that even makes it worse.
Oh yeah, were you flat earthers at the same time?
Yes.
Oh,
he was. I think he was a flat earther like 2 or 3 years longer than I was. Well, but he was like in a transition where like for like a year or two, he was like on that hard fence where he's like, "You're both wrong." So
Flat Earth Messiah, I know him as. So it
Say
can't,
again?
be, it can't have been that long ago.
Say it. Say again.
Babs.
That's a few years ago.
I remember him claiming himself the flat Earth Messiah. Can't have been too long ago.
Yeah.
I never
Yeah,
seen
it
him
would have
as a
been about
flat earther.
that'd have been like maybe 3 or 4 years ago, but it's been a while since even before he left Flat Earth that he was kind of on the fence arguing against both sides, like trying to figure it out. But he wasn't a diehard flat earther
That's
3
that's
years
where
ago.
all the glory is now. He's a concaver, so he's saying that both are fucked.
Hey, Bev, I put up another diagram. Would you disagree or agree or disagree with that diagram?
Yeah, I disagree with that. It looks like that water level's dropping off. The whole red thing.
Okay, anybody else look at that diagram? Do they concur with Bev?
I gotta go to what diagram? Okay.
Paralogizing. Right, Larry?
No, what did you say, Bev, about it? Because what Larry put in there is what I've been trying to tell you to do for years. But go ahead.
Looks like a slope, doesn't it?
Bev said straight off that the tops of the water columns will be following the horizontal, not the constant elevation. That's what Bev just said 20 minutes ago.
Yep.
Larry. Yeah. You're talking about his water level test. Yeah, I've been telling. I think you said it a minute ago.
No,
Bev
Larry's talking about
cite,
in reality, aren't you, Larry?
You're not
talking about the realizing Euclid test or anything, are you?
Hang on.
I'm realizing.
Hang on, Larry and Bev, because I'm going to finish what I was saying before I interrupted you to interrupt me. No, that water level test is reality, and the diagram that Larry put in would be the equivalent of the diagram that you guys did. And when we say, did you cite your water level, actually creating that horizontal, you keep telling me you don't have to. But we're telling you, if you want to know if there's curvature, because you keep saying there's not, that's what you would have to do.
Yeah, but that's
so
the elevation profile, isn't it?
Yet?
Larry, you're doing that. That's on the vertical plane, isn't it?
Yes, it is. And as you know, the tops of every water column in a water level will be a constant elevation.
Absolutely. I'd call that a horizontal plane, though, Larry.
Well, that's the problem.
But it's not.
Because you can see in that diagram, it is clearly indicated what the horizontal is and what a constant elevation is, and the water level adheres to the constant elevation. That's reality.
And it shows a complete difference between level. It shows the complete difference between level and horizontal, especially in the context we're talking about.
Yeah, you should label that rumpus pole.
Why?
Because that's the unit of measurement between level and horizontal over distance.
Larry, he's only trying to discourage from exactly the point we're trying to make about that level and horizontal line.
You make up any kind of childish words you want to, Bill. It's okay with us. We don't have to use them.
I'm just practicing the rhetoric, Blue.
No, you're just practicing being a child is what you're doing.
No, no.
Yeah, let's just see what.
What would you call it then?
I call it being a petulant child. Yeah, that's what I call it.
The unit of measurement between level and horizontal over distance. What would you call that?
Let's just see what a textbook says. Let's go outside our realm. Let's ask other people. So I put up a textbook citation. And which does it agree with? Your description or the diagram that I posted?
Well,
I have citation concurrence. You have nothing.
Elevation is a vertical change from the horizontal, right? It's on the vertical datum.
Do you understand that curvature is in question, right?
A constant elevation is approximately a 3,960 mile radius arc.
No, a change in elevation is measured on the vertical datum.
A vertical datum, yes, which is radial to the planet. A vertical datum is radial to the planet, yes. Normal to the geoid.
Yeah, so that's where the equipotential angle comes in. Because it's the adjustment that you have to make over distance. We've already
No, I
been
don't
over
make
this. I'm not too sure you know.
I don't make an adjustment.
I'm just asking you
I
what
apply.
you would call that distance.
I don't know. I can't be any more clear. And so let's look at the textbook. Why don't you disagree with it?
Well, a vertical change, like I say, because I've done surveying, may have been a few years ago, right? May only been just normal surveying, right? But a measured change on the vertical datum is a measured change of elevation.
And look in the diagram from the textbook what an elevation change is. It's on the arcs of constant elevation,
but it's
not on the horizontal
by
at
the level. The level provides the horizontal plane, and the change in elevation is measured on the vertical from that tool.
Well, there you go. And once you apply, once you apply curvature correction, then you can determine an elevation from the horizontal and applying additional maps.
Yeah, so never
He
really
just doesn't want to do the
just
next step, Larry. That's the problem. He wants to do the datum points and the elevations, and then we're saying that next step, and he's going, I don't have to do the next step. I'm just going to describe the elevation points that we keep talking about.
Hey, you can paralogize it as much
next
as you
step,
want, mate.
No.
You're
the
only
next
fooling
step
your friends.
is the important one.
Maybe they're not your friends.
It's not fooling anything.
Have you ever
anybody? It's just reality.
Have you ever extended a horizontal more than a few hundred meters?
Yeah, you do. You do line runs, don't you?
Yeah, I extend a horizontal 27 miles, and the tower was below it. Just like in this diagram.
How many transitions did you do?
0. It was a 28-mile singular
you have to
observation.
do the transitions, don't you?
Yeah, you know.
For measuring elevation changes. Close the loop.
Or measure the angle, or measure the angle and do the additional calculation.
I don't understand why the next step scares you so much.
Hey, paralogize it as much as you want. Like I said, off you go.
It kills his rhetoric, Sean. That's what.
Like you're literally going. You're going. I've done grade checking, therefore I know the shape of the Earth.
No, I've not talked about the shape of the Earth at all. Everyone
I
knows his globe, right? So we're just talking about our understanding about horizontal planes and 2D surfaces.
Backtrack. Okay.
I can lay out an all-day parking lot. I'm a surveyor, right, Bill?
Would you describe? Would you describe?
I'm not a surveyor.
Would you describe a large body of water as a 2D surface?
No. No,
what?
You called it a body, so no, I wouldn't call that a 2D surface.
Yeah, that is true.
How is a body a 2D surface?
Well played. Wait, what? Because it has depth.
I've seen a body, and that definitely wasn't a 2D surface.
Everything's meant to be a 2D surface, though, so watch what you're saying.
Can you change that to surface?
Welcome to the globe, Bev.
Tis globe, come on.
Hey, Bev, let me ask you a question. I know this topic is your soul, your go-to, but do you talk about any other topics?
Yeah, we're getting into talking about broken minds.
We were doing that last night with the Mandela effect.
Which, again, Dan did a good fucking job.
Yeah, I really enjoyed that.
But more important than all that, this Sunday, I finally get to debate Brian Leakey.
Yeah, after both showed up to the event at different times and ran away in fear at their own expense multiple times, we're finally tying you both to a tree. And we're gonna watch it happen.
Yeah, you say that, but what's really happening,
What,
people,
without a
is me and Brian are
fee? I thought
telling
he
me and Brian.
charged.
Jesus, hang on, damn, Beth, hang on.
He said he'd
Well,
never
never
do
mind. My
anything unless
punchline
you
and
paid him
the
$5
layout of
grand.
it's fucking gone now. Fucking A, we got another fucking Cole in here.
Oh, let's John get his point up.
I know it's worthless now. I was setting up for a good joke and he fucking ruined it. I can't start now.
Let's hear it, John. It's gonna be
Nope,
funny,
can't
isn't
do it
it?
now.
Sorry
Nope,
for
not
heckling
anymore.
from the crowd there, Sean.
It's funny. Sean interrupts everybody all the time, but then he wants to say, "Got another Cole in here." But he's like the worst
Yeah, but I
person in
do it
the
on.
room to
I stay on
interrupt.
topic. I
Hey,
stay
Cole,
on
we were in the
topic,
middle of
Cole.
something. Could you just please not interrupt? That would be great.
Yeah,
Yeah,
fucking
and
mute yourself. Fuck.
and he also thinks that he
More than
knows
one
a lot more
sentence.
than what he really knows too.
Shots
I
fired.
know a lot more than I realize I know.
Self-proclaimed genius.
Go back to sleep, Cole.
You guys,
You can't.
apart from
You
Sean,
Go
gotta
are
back to
work.
pretty good at
curveball.
mic control. I must admit that.
Hey, put it this way. Put it this way, Cole. I've never driven a train and had to go backwards because I missed the switch. Team 0-0.
You got a point, Cole.
Yep.
You did have to go backwards.
I can't even make it go forwards right now. I'm sliding down a hill and I can't even get it to go the right direction.
Yeah, if anyone wants to join the panel tonight for dissecting flat Earth videos, go ahead and DM me or at me in the chat, and I'll send you a link. 'Cause it will not be inside of Discord.
You want to do the one where Nathan
think that-
Oakley says that XYZ is a plane?
You're talking about in
How long is the clip?
if you want to share it, we can play it now.
It's only a 14-second clip. Let me get it.
He said a lot of weird things.
Yeah. But it goes along with what, this 2D plane thing. There you go, it's in the chat. Coming in.
XYZ is a plane. Okay. So you were wrong, Stingray. Z is part of a 2D plane.
Mm-hmm. Much like
He
thinking
said
the
so.
sphere is a 2D thing as well. That's a plane. So, like I say, there's not much difference, really, when it comes down to it. I think Nathan Oakley might be a secret glober.
Just to correct you,
But
Bev,
the Z-axis...
no one in here said a sphere is 2D. Not one person, no one.
Well, the sphere exists within the XYZ, right? And Nathan Oakley thinks that's a plane.
Jesus Christ. Hey, Bev, do me a favor. I know it's going to be difficult, but we're trying to teach Stingray to talk, so I need you to say Z, not Z.
No, he's on my side.
Oh, wait, no, I don't think he is.
The origin
He
of the fucking
actually
English
isn't
language
much
as
of a
well,
problem.
Sean, just so you know.
Yeah, but you say it funny.
Sean, we're never going to teach Stingray to talk. We tried years ago and it didn't work then. It ain't going to work now.
Lost cause.
I have hope.
Well, yeah, again, it's the
I
surface that's
haven't
2D,
given up on you,
not the
Stingray.
volume of it.
Wait, isn't the surface 3D?
No, the
It
object
can't
is
be.
3D. The
What you
surface
just
is
saying,
2D.
Sean.
Wait, what?
Said
I can't listen
it
to
said
this
it
two
can't
at
be.
once.
Surfaces have to be 2D. All surfaces. As
Explain.
much as it may sound like a flat earther.
No,
That's
just
the
explain because
dogma.
I can see, because it has width, it has height, and then I can tell. I see depth. I don't know if maybe your guys' eyes are fucked up.
No,
No,
I'm
the
saying
object.
I'm with you, Sean. Like definitely
There's a
3D.
difference
When
between
I
the
see it,
object and
I
the
see the
surface of the
3D.
object.
But I don't see the 2D surface of the 3D object. I see the 3D object. Completely
That's what I'm
bypass
thinking.
this 2D surface. Me?
Hang on, because Demon Strike was going to say something. He doesn't talk with his chest, so he talks a little quiet sometimes. So go ahead, Demon.
I said objects are 3D. Shapes are 3D. The surfaces of those objects are 2D.
Yeah, that sounds
Okay.
like
The problem
military
is,
shit.
if I is a piece of paper 2D or 3D?
That's 3D. The surface
Okay.
of that piece
Is
of
the
paper,
surface of
though,
Earth?
is 2D.
Wait, what the fuck?
Both surfaces.
Right.
All surfaces are 2D.
Like, I mean, I'm saying of the piece of paper, the front and the back. You're not calling that a surface because that's like twice. Isn't it?
Okay, hang on. Stop. Hang on.
Yeah,
Okay,
everybody
I'm
has to hang
standing.
on when Sean
I'm
says it.
standing. Shut up, Stingray. Yeah, see how it works? See, look. No one's talking. Okay, so I'm standing in the middle of the desert, and there's a flat fucking basin in front of me. I have
Is this
a
going to be a
set
long
of
story?
mountains. Fuck yeah. I have a set of mountains and then another set of mountains behind it.
What's the weather
Yeah.
like?
I can see, I have depth. So how is that not like, I don't get it.
Yeah, I know you don't.
The surface, I know. So why don't you fucking explain it?
Because no one
So
cares
your
enough.
body, all right, just imagine
Yeah,
like
see, someone cares, Stingray.
your
Dick.
clothes are like the surface area. Your body is the shape, right? Like imagine like your shirt wraps around your body, right? But if you were to cut your shirt and lay it down, you could lay your shirt completely flat on the ground if you cut it in all the seams, right? It's 2D
Not
wrapped
so
around
sure
a
you
3D
should be
shape.
equating it to flats, should you?
Hang on, I have a better question.
Watch him. Keep an eye on
Define
him.
the 3 dimensions in 3D.
X, Y, Z. I mean Z.
Fuck you. Okay, what do they represent?
Length, width, depth, and height.
Okay, now hang on.
Surfaces
Okay,
don't have height.
yeah, but that's okay. Hang on. When I'm standing here looking at the scenery,
Yeah.
what don't I have about length, height, width, and depth?
Because the surface is only 2D, so it doesn't, like, even though it goes up and it changes angles, it doesn't get any thicker. So it's just a skin on
Length,
top of
height,
all of
width,
the
and
shapes.
depth. That's 4. Did you just
Yeah.
sneak in an extra dimension?
Yeah, he did say 4.
Nobody else noticed that, did they?
Yeah.
What?
It's the
Why
did.
didn't you lot listen to that
does
there?
it all
Why
the
didn't you
time.
call him on his
We
4th
did, but
dimension?
it'd be
You
friendly
slipped it in
fire,
without you
Bev, it'd be
hearing
friendly
it.
fire.
What
Everybody
Demon
noticed it.
Okay,
It'd be
hang on.
friendly fire.
What Demon was trying to say is there's no
Hang on.
depth to this.
Trying
Go
to
ahead,
count the
Sean.
dimensions, right, Sean?
Okay, but do I see depth?
No.
No, you don't
actually
look
don't.
I don't
into it
see.
at all.
Wait,
Sean,
time out. Wait, time out.
No,
I
Sean, you
have a
don't see
TV in
depth.
front of me and a door behind it. I can tell that door is further than that TV. That's depth
You
perception.
Sean,
You can't tell how
perception-
thick it is.
Yeah, perception is not you seeing depth.
What the
That's you,
fuck?
Well, think about it this way: you got rods and cones in your eyes. Do they see 3D, or is it the stereoscopic nature of your vision that allows you to perceive that there's depth?
Why the fuck would you ask me the question that way? We are literally trying to help me understand why we don't see in 3D, and you wanted to go into some technical jargon like we both have been studying it for years. Try again, Stingray.
No, no time.
You
I
just
don't
need
know
to calm
nothing
down
about
and
the eyes,
focus.
so everything you said
Here we go.
means
There's a
nothing.
very good reason a cat or an owl moves its head side to side. What it's doing is
Oh my
gauging depth.
God.
Because listen. What it's doing is gauging depth. Because without moving its head side to side and perceiving parallax, it's very hard to figure out how far do I need to fucking jump to hit this bird.
Again, that doesn't matter though. Like looking down,
Yeah.
compressed depth, or like you're on the surface looking at shape, right? When we talk about surface, you want to get a drill out and put it through the floor you're standing on, right? And the surface has no depth. It is only 2-dimensional. And like think about it in a
Okay.
video game.
Okay.
Like the skins on the video
Okay,
game
hang
is just yeah.
Okay, so I think I see where the problem is. When I'm talking about me seeing something, my eyes, that is in 3D. I don't give a fuck what you say. I can tell my table is 2 inches thick at each leg, blah blah blah.
Yeah,
But what you're
nobody's
saying
disagreeing
is
with that.
the surface of the earth, not what I'm talking about, the surface alone. Okay, I now get why it's 2D.
Yeah, so if you cut the like if you took the skin of the surface off with all the colors and everything, it would, you'd pull it away and you could lay it flat. You could cut it in a bunch of ways and lay it flat, and it would be zero
Okay,
depth.
I get it now. Yeah, Stingray. That's how you explain something to somebody.
Yeah, but the surface of a sphere is a non-developable surface, right?
Doesn't make any difference.
Sean, that's if you want the person that's speaking
Oh
to
my
actually understand it. So there you go.
I can't understand you. So how am I going to understand it?
You don't understand us.
Well, Bev, if you think about a soccer
Come on,
ball,
you did admit that it was 2D, so you capitulated in the end.
No. But see, now I understand why. I understand why I think it's 3D, but I understand why it's 2D.
Yeah, it
that's
has to be
the
2D,
reality.
right?
That's
You may imagine that it is 3D, but you understand why it has to be 2D.
Surfaces are bound.
Wait, what did you just say? What did you say, Bev?
It appears to be 3D, right? And you see it as 3D, and you live in 3D, right? But you understand now why it has to be 2D, right?
No. I understand why it's 2D, not why it has to be.
It has to be.
There is no explanation for it. Why? No. There was no one at all. Even Stingray's shitty ass explanation. No one said anything about why it has to be.
No, I said it has to be. Like, it's a good job you capitulated.
But it doesn't have to be. Right? You agree. It does not have to be. You may say it.
You try opposing them. You try opposing them. This is dictated by the dogmatic nature of the model.
And then they explained it to me, and I used reality and I used understanding and explanation to come to a conclusion. And the conclusion is, Bev, I see in 3D, you see Earth in 3D. Absolutely. But the reality is the surface, not what Bev sees, not what Sean sees, the surface is 2D.
Well, 2D is conceptual, right? And everything in reality, like you say, is 3D. So you can't actually see 2D because...
No, you can't actually see 3D.
Well, yeah, you can. You can see within reality, yeah. See, Sean can.
Yeah,
I'm telling you right now.
Well, actually, wait a minute, Sean. We might have to capitulate. Everything is 2D. The surface of everything is 2D. So therefore, everything that you see must be 2D.
Incorrect.
What?
When you look at
I don't know, Globe Dogma.
Incorrect. When you look at
that confused me.
Yeah, Stingray will tell you.
When you look at a surface from outside and you see that surface exist in 3D space, you can define it as a 3D object because it needs 3 sets of coordinates to define the surface. If you're on that surface and you're only dealing with what's on that surface, it's 2D. Your eyes only see 2D. Otherwise, you'd be able to see you'd be able to see the depth of fucking objects.
That's not true. I'm looking at a cup right now, and I can tell. I can see all of its dimension.
Well, we see in parallax, so we do see the.
Yeah, when I close one eye, I still see it in the same fashion.
You can't see the fucking back of it, Sean.
You can turn the object.
You're right, but I can see height, depth, and I can see it all. I can see the thickness of it. I can see anything you can describe about a 3D substance object. I am staring at it and I can distinguish between those.
If I
You
show
can
you a
perceive
cube,
depth.
if
That's
I
the
show you a
thing.
cube really close up, whereby you can only see one face of the cube, let's say it's a massive dice or something like that, then if you could see 3D, you'd be able to see a fucking cube. You can't. You see a square.
No.
No,
That's
hold
not
on,
true
Dave.
because now you
You see
just said
objects in
if I
3D.
put something if I put something so close to your face you can't perceive what it is. But if you could see in 3D, you'd be able to perceive what it is. Do you realize how ridiculous that sounds?
That's
We
not
do
the
see in
important.
3D, like we see in parallax. You see depth down things. Like when I'm playing my 3DS, right? It's got a flat screen, and when I turn that 3D slider on, all of a sudden I see into the device as well. I see depth. It's not just X Y. It's X Y Z.
Right. So very important there.
Thank you.
You see no.
Now, I can explain to you how you
Wait a
don't
minute.
see Z.
Wait a minute. Very important there.
Wait a
You
minute.
see two 2D
Damn it.
planes, and the angle of convergence of your optics, both eyes, the fact that you're now seeing two different images allows you to perceive depth. However,
Yes,
it's still 2D. If you could see 3D,
you're getting 2D images through two of your eyes, and they're combining it into a 3D image.
No.
But the
Yeah.
important thing about what Stingray said, and he got wrong, is the symbol of dice is die.
No. Yeah. Okay. Well, is it though?
Well, hold on. Is the definition of seeing in 3D being? No, hold on. Is the definition of seeing in 3D being omnipotent, being able to be omnipresent
Stingray
and
is
see
very
every angle?
omnipotent.
You can only see the 2D surface of the sphere, though, can't you?
No. You can see what looks like a 3D sphere. You see the fact
you
that
see the 2D surface,
by
though,
the
right?
oh my god!
No.
You see
The surface is 2D
perception of
because
a 3D
you're not seeing
sphere
it.
only in
You
perception.
suck at this, Stingray.
That's your brain interpreting it. You do not see 3D.
Yes, you do.
You see two 2D images that your brain.
So what? We don't see 3D,
parallax
but we don't look and see the 2D surface of the ball either. What are we seeing then?
Your eyes
I
see
don't
in 3D. Your
hey, look,
brain
I
combines it
don't
into
look.
3D.
I don't no.
Why
I don't
is
see a
vision-
portrait when I look. Hang on. I don't see someone that paints a portrait with like mountains in the background and a meadow and blah blah blah. I don't see that. When I look outside right now, when I'm looking right now, I see depth. I don't perceive depth. I see depth. How do I know that? Because I see the roundness of the cup in front of me. I see the angle of my TV. I see the angle of my door, and I know how far that is. And I can see how thick all these things fucking are. I do see in 3D. I see the roundness of a castle that's on the shelf right now. Like, I do see in 3D. You keep saying perceive,
Sean,
but if it's perceived, you have depth perception problems.
No, that's
but I don't-
perception. Perception is something different. You can perceive things that are not there. You can perceive things that are there, and you can perceive things that are entirely fucking made up. You do not see 3D.
No, wait. Made up. What the fuck? People that have bad depth perception don't see illusions. What the fuck are you talking about?
What is your definition of 3D? I think maybe that's the problem. What do you mean by 3D?
XYZ.
Okay, question.
What?
Oh, right, Nathan Oakley, the plane.
I have a question. We have two eyes, and in my mind, I yield one vision based on the binocular vision of two eyes. So since I only have one image in my head that's formed from two eyes, yeah, I do see something which is more holographic than anything else. Yes.
Well, the light
I close
hits
one eye and I still don't have this problem.
Can you
the
see
light
past
hits
the
the back.
2D surface of everything?
Hold on, let Cole in.
Go on then, Cole.
Why?
Can you stop with the disrespect? Honestly, the light hits the back of your eyes. Basically, the back of your eyes. I know it might be slightly curved, but it's pretty much like hitting a flat wall. Your brain does not know if the light come from further away or closer away. The light's traveling at the same speed. So your brain literally has to take light that hits basically a flat surface at the back of your eye and then interpret it into a three-dimensional world.
Yeah, so here's a very important thing. On singular lens
Yes,
optics,
I see in
you
3D. Thank you.
No, you don't. In singular lens optics, you can perceive, you can actually run a vision neural network to gauge depth. Now it's estimating depth of a multitude of different factors, the same as your brain. Not as good as your brain, but it actually does do depth fairly well. If you add two 2D sensors to that, that still doesn't give you 3D. You cannot see the depth of an object that is outside the field of view of those 2D cameras. You cannot. You can gauge it or perceive it by the convergence and figuring out parallax as well.
Stingray, are you gonna get like one of those sex robots? Because you seem like everything has to be through the eyes of a camera or a robot. We're talking about my eyes. And when I say I see in 3D, you say I perceive things in 3D. It's the same fucking thing.
No, it isn't.
Okay, Stingray. So you're telling me objects aren't 3D? Okay, are objects 3D?
Yes.
Does my brain make my eyes perceive them in the reality?
It makes them perceive a 2D perspective transform hitting a flat surface of
Oh
all those 3D
my
objects. Yes.
God. You are so ridiculous. You can't even answer the question because you have to add gibberish.
No.
Just answer my question. Okay. I say I see in 3D. Are objects that the cup I'm looking at, is it in reality 3D?
In reality, it's 3D, yes.
Okay. Does my brain make the wall in the back of my eye? I don't give a fuck. When I look at that cup, is it in 3D?
Are you perceiving reality as
you perceive it with your eyes that are capable of receiving 2D?
Yes, but do you perceive it as a 3D object, or do you perceive it as a 2D object?
You perceive
okay.
100%.
Thank
you perceive it. You do not see it.
Thank you.
You perceive it.
Yeah, I see it. I perceive and see are the same fucking things. Fucking A.
Yeah, the image my eyes see, right, are converted in my brain, and I perceive the thing I'm seeing. I don't see what I'm seeing ever. You never see what you're seeing. You only perceive what you're seeing. You cannot see with just your eyes.
I don't normally
You cannot see with just your eyes. They are not cameras. That's the thing.
Wait a minute. I don't normally do this because I don't agree with doing this a lot of the time. But I've done a search, a Google search, and I've just put, do we see 3D? And the explanation that Google comes up with, we are 3D creatures living in a 3D world, but our eyes can only show us 2 dimensions.
Yeah, and
but
we
I can see in 3D.
What our eyes see. That's the thing is, yes, your eyes present a 2D image. It's a 2D stereoscopic image that your mind then perceives. Show me one person who sees with just their eyes and not their mind.
No, I've just said we perceive depth. We do not see depth.
That is what we're talking about. Semantically, we've agreed multiple times now that eyes see 2D images that the brain converts to 3D. Because when we talk about seeing, we are not talking about the static input from that our eyes are receiving. Because it's fucking upside down. If you were just to see with your eyes, technically you see everything upside down.
You don't perceive 3D. You perceive depth.
Oh my God!
It's the third dimension, right?
Wait, hey, you perceive 3D. Hey, look, you perceive like your brain your brain makes it so your eyes can see in 3D. The only step away from 3. Oh my God!
Sean's got it right. You see with your eyes and your brain, not just your eyes. Seeing requires your brain, your eyes, and everything. So,
okay, let me explain this.
When you see,
no, Stingray, let me make this real clear to you. Hang on, Stingray. Let me make this very clear for you. The cup in front of me, it's 3D. I see it. The light hits my eye, goes into my eye. My eye goes to the back, and then my brain perceives it for me to see in reality. So I do see in 3D because thanks to my brain, it has perceived it for me.
Yeah. Your eyes record in 2D. That's
okay.
as
So
far
that's
as it
like
goes.
saying, I can perceive a unicorn, therefore a unicorn is real.
Oh my
Because my
God!
mind
Now you're
can make
making
up a
mythical.
unicorn.
Now you're
No.
adding
What?
mythical creatures.
What?
No one said you can see ghosts, motherfucker.
Yeah, you can't perceive a unicorn either with your eyes.
No, but what about the mind?
You actually can.
Stuff, right?
Actually,
if
you
mind
can
invent
because
it, it must be real.
those one antelopes with the fucking straight antlers. The fucking
Yeah,
old time European people used to see them and think they
Okay,
were a
here's a
unicorn.
question
So
for
you
you,
can
Sean.
perceive.
Sean, here's a question.
What?
Listen to
What?
this. I can take an image with a camera. Yeah.
Oh my God!
Now, what?
I don't care about your
Listen,
cameras, you fucking
just
camera freak.
listen. Nearly there. I can take an image with a
No, you're
camera,
not.
and let's say for every single pixel in that image, I also get the distance from the camera. Yeah. Is that recording a 3D scene of reality? Yes or no?
No.
What if you took two
Then we don't
parallax
see in
images
fucking
though?
3D.
What if you take
Oh
you
my
take a
God!
picture with two parallax cameras, okay, and you put them on the screen, and all you got to do is cross your eyes to see what you're looking at. Then is a 3D
Boom.
image. You're perceiving 3D of two static 2D images.
I can't.
Your
Why
eyes
can't you
record
just
in
realize
2D.
that we're sticking to
Your
the
eyes
eyes?
record in 2D. Yeah, your eyes record in 2D. Nobody records. Sees what they're recording. They see what they perceive. Your brain perceives things for you.
That's a great way to explain it to them. Yes, your eyes record in 2D, but you view it in 3D, motherfucker. You view it in 3. You view. Let's go look at the source. See, perceive. Oh shit.
All right. So here's a very simple exercise then. If I've got a box and there's random fucking numbers written on each side of the box.
Oh my God.
If you think I can see in 3D, perceive, whatever the fuck, and I look at the box, can I read all the numbers?
Nobody's saying.
No one's saying you can do magic.
That would be omnipotent. That you would be omnipotent if you're able. Yeah.
Fucking day.
Why? I don't understand that. So maybe there's a semantic barrier that you're stuck behind right here. I'd say that's seeing in 360 or something. Like I don't get why you would be able to see through things if you're seeing in 3D. That doesn't make any sense. Yes, Superman vision. You can now look through walls just because you can see in 3D. You would perceive everything in 3D at that point. You don't see in 3D.
Stingray.
You perceive things as 3D.
This is not a good day for you, buddy.
Well, arguing with you two assholes, I'm fine with that. That's fine.
And being wrong. Don't forget that part.
To be wrong, first of all, Sean, I have to accept that I'm wrong, and I am far from fucking that with what
No,
I'm saying.
that's not true.
He's never
true
going
at
to
all.
accept it.
So that means flat Earth is real, Stingray, because they all accept it as real.
No, I'm just saying
that's what you said.
My opinion of me matters more than everybody else's in this channel opinion of me. So there
Okay,
you go.
what is your opinion of you? Okay, fine. Let's see that base level. What's your opinion of you when you look in the mirror?
What's
2D or 3D?
Everything's 2D,
What?
so that's the answer to everything now. 2D.
The Stingray is. See,
Yeah, you
Bev,
only see
I
2D.
understand why.
We can take an
Sounds
image
like a flat earther, doesn't it? It really does.
No,
To
we
anybody
can
outside this
He
arena,
does.
they'll think,
we can take an
"Whoa,
image
you're the
and
flat
we can
earthers
see
here. That's
that
crazy."
we can perceive that things are in front of other things and things are behind other things. We can see or perceive that. Our brain is inventing that for us based on probability and based on reinforcement learning.
Yeah,
and
you were laughing
based
at
on
Nathan
what we
Oakley
know.
saying
We're
XYZ
determining
was
that.
a plane. You're happy saying XYZ is 2D.
Well, yeah, my brain
What
is
the
not
fuck is
imagining my brain isn't imagining anything when I'm looking at it. There are definitely things that my brain will fill in, like the edges of my vision. It'll put color there based on the core at the center, but it's not imagining things you're looking at. I mean, you're somewhat hallucinating reality, but
Demon, imagine that. Just hear me out. You're looking at that image that Bev showed of, the Leaning Tower of Pisa and Blackpool and all that kind of stuff, and the mountains in the background.
Look at Larry's picture with the tilting.
You can see
vertical
or perceive that those mountains are behind, right?
Yeah.
Yeah. Now
They're
that
not
image is
an
that
intelligent
image
parallax
is
is a 3D.
that image is entirely 2D. You are looking at a
Yes.
2D image, and the light hitting
Yes.
your eyes is 2D. How can you
Yes.
tell that those mountains are behind?
Based on having had parallax and understanding what,
There's no parallax in
you know,
that image.
3D. Hold on, I know, but having parallax in my eyes and being able to look out at things, I understand that things are behind other things are generally further because I can see that, I can see depth. So when I look at a 2D image, it's like, oh yeah, okay, that's most likely further away because that's how things get behind other things. But if I had two parallax images, I could perceive that depth.
Yeah, quite potentially. You can perceive that depth. You can gauge that depth, and your mind makes it up for you. You cannot see it because if you could see it, as in sensory perceive it, you wouldn't need to make it up in your mind. You'd just be able to see it.
The problem is you're trying to equate our brains and our eyes to cameras, and they aren't. And the wording, I think, is what you're getting stuck on. Seeing this or that, like fuck. Seeing is what you do with your mind. Okay, you don't see anything with your eyes at all, ever. You use your mind to see things, and you perceive them in 3D if you have two eyes, and you don't have like a fucking lazy eye. Because I get this, even if I try and imagine something, I can't imagine in 3D. If that's what you want me to do, be able to see the numbers on the other side of a die in my head, I can't even do that. Can't even imagine in 3D if that's the case.
Okay, so do you think someone with a single eye, an eye patch, a pirate, can see in 3D?
No, they see in 2D.
Can they perceive?
Because their mind,
Can they perceive?
they can only they can perceive in 2D. They can understand something's 3D, but when you look at it, they cannot perceive it with sight of its third dimension. That's lacking, always will be.
Okay, now can they perceive depth with one eye?
No.
You can actually perceive depth with one eye. You can do it based off size recognition or parallax, and that's exactly why, like I mentioned before, cats and sometimes
Yeah,
birds.
so if I'm judging off of other objects, I'm not seeing or perceiving that 3D. I'm gauging. I'm making an assumption based on reference frame.
Yeah, so that's what I call perceiving.
That's not what I call perceiving. I call perceiving is what is presented to you. So I would perceive that everything I'm looking at in 2D. My brain is perceiving it. All the other shit your brain does, filling in the gaps, whatever. You do that for color and other things, but not for depth.
Yeah, you see,
Well,
I'm
that's
going with
what-
the dictionary definition of perceive, which is to become aware, conscious of something, or realize or understand it. To realize that there's depth here is to perceive depth. Not that I've seen it.
Right, so it's a semantic thing. I get it.
See.
I get it that it's a semantic thing, and that's kind of what I was pointing out at the beginning.
So see, perceive with the eyes and discern visually. I cannot see 3D, but I can perceive depth. I still stick with that.
You are perceiving 3D when you look at a stereographic image or stereoscopic. Your mind perceives 3D.
It perceives depth.
Whatever. Again, a semantic thing. You know what I'm saying. But yes, your eyes never see 3D. Nobody sees 3D. That's not possible. I can't even do that in my mind. The world around me I perceive as 3D because I have two stereoscopic images that are converted in my mind to see.
object, a random object. Yeah, it doesn't matter what it is. Say you've never seen it before. And can you, in your mind, imagine what that might be on the other side that you can't see?
Yeah, I can imagine, but it doesn't mean like if I imagine like a 20-sided die and I want to see the numbers on the other side, it becomes like translucent in my head, and then I can see the images. But if you just want, like, what you're asking is to be fucking omnipresent and be able to just always like perceive every side of it, like that is fucking crazy. So that's a crazy concept even.
Well, a 4D being, yeah, not a 3D being, but a 4D being could see in 3D.
Yeah, that's what I said. I said that earlier. I said if you could see in 3D, you'd be perceiving everything in 4D.
I must have missed that. That was quite good. So as long as we know that we can't see in 3D, I'm all good with that.
No, you can see 3D. It just depends on what you mean by seeing.
The dictionary definition.
Well, you can use the dictionary all you want.
I know, it's the way that we rationalize words and communicate better. Let's all use that, shall we?
Yeah. What does your dictionary? What does it say for the word Z? Does it say Z or Z when it goes to pronunciation?
If you go from one place to another and you take a path, what have you plotted?
A squiggly line.
No, I mean, you're going to follow another word for a path.
Journey. Destination.
No, that
Adventure.
A road.
Begins with ah. Well, anyway, you guys say route, don't you?
Route.
Yeah, I would say route.
The route.
Root. That's what I say. Like
No,
Route
root's the thing
66.
root's the thing that grows on the bottom of trees. A route is what you travel across.
No.
There's no W in route.
Root is what grows on the bottom of trees, but route is also what you travel on.
You're both wrong. It's Route.
And it sure ain't Zed, Stingray. And math don't have an S on the end of it. It's not math. And where you can't even hardly say that. I don't even know how y'all say that. Math.
Yeah, well, it's really easy, Cole. When you invented the fucking language, you just stick to what you invented. You let other people mutate it to the lazy version.
And there was another. Oh, you say you go to the university, or I went to a university, not to university. You don't go to hospital. You go to the hospital.
I need hospital. I'm leg broke.
But you do go to college.
Ridiculous.
Yeah.
You
go to
college.
university, not to university.
No, you go to college. You also go to high school.
Yeah, fuckers.
But
Thank
you go to
Cool,
a
right?
university, not just I go to university.
Yeah, do you go to? I suppose you do. You go to college. You can.
Yeah, no, it's the institution.
University is a fucked up one.
It's the institution as opposed to the place. You go to the place, but you go and join an institution.
Yeah, it's their equivalent of saying going to college. They just don't like Americanized words.
So you've got, well, you call them malls, we call them shopping centers, but we don't say, because
the first indoor mall was actually invented here in Minnesota. But I mean, you guys can, take whatever name you want for them.
The what now was invented in Minnesota?
the first indoor shopping mall.
I'm going to look that up because that sounds like bullshit to me.
Yeah, go ahead. And then you can pat me on the back when you're done. I believe it was in the 70s. It was Rosedale. Or Roseville. We also invented the pathways, the skyways that connect buildings so you don't have to walk through the streets during the wintertime.
Oh wow! It says you've got the Mall of America, which is the largest fucking
Yeah, that was
in the
made in the
United
90s.
States.
Yeah. It was the largest in the world, so I think China or something made another big one. Similar.
So when was your mall opened?
Looks Stingray, I'm playing my train game.
Damon, when was your mall opened?
I think it was in the 70s.
So
How about
wait a
1950s?
minute. So I'm going to butcher this, but the Galera Vittorio
Oh,
Emanuele
1956.
II opened in Milan in 1877 and was indoor shops.
There we go. Yeah, it says it's the Southdale Center in Edina in 1956. The first
Wait
modern indoor
a
mall
minute.
in the U.S.
Wait a minute. So the Burlington Arcade, which is indoor shops in London, was opened in 1819. So I think your claim, I think I've made it stand
All
up
right.
to be bullshit.
Yeah, all right. It's the first one in America. Again, I guess
Oh,
that's
yeah,
why I didn't
that's all
think
that
about
counts.
everyone else. Yeah, it is all that counts, honestly.
Yeah. Just rule out the rest of the world. That doesn't matter.
Well, we
It's
knew
real
what
easy
demon
to,
meant.
honestly.
We
Hold
knew what
on,
demon meant.
Stingray, but you're not wrong. You're wrong. This is the gallery, however you pronounce that word. That doesn't look indoor to me.
Oh, it is.
Does it just have walls up around it and open roof,
Probably in a shed or something.
dirt floor and everything?
That's outside. Look at inside.
Oh, is that okay?
Yeah, it's got glass. It's got a huge, very, very old glass roof that covers it all.
Okay, I see what you're talking about. First picture
No,
was
it's still
deceiving. I
wrong.
apologize. I was wrong.
Where did you put these images?
Open chat.
I only see one. It's the outside, and it's from Drink a Kool-Aid.
Yeah, here's the other one. That shows the inside.
Maybe the one in London was before that as well, just so you know.
Yeah, but could you buy guns in it?
Back then, possibly. I'm not going to look into it, but quite possibly, yes. Because unlike yours
Oh,
that
what you're
came
saying is
around
you
after
guys
the
used to be
invention.
cool.
Wait a minute, Damon. Unlike yours that came around after the invention of the fucking gasoline-powered car, we probably had this shopping mall when there were still pirates.
All I'm hearing you say is that you guys used to be cool.
I cannot disagree with that statement.
Like, what's the definition of a mall or a shopping center?
Yeah, well, that's an interesting one. I just read on the Wikipedia. Well, I couldn't understand yours for mall. It seems to be surface area, which is a bit weird. I've yet to look into that. But the others, a mall, a center, they're just classed as inside, weatherproofed areas for multiple shops. But the mall is like I tried reading and thought I got bored when it was trying to define it in Wikipedia.
Flatside's not live tonight, guys. You best put the word out. There'll be an audience if you're going live. I've put that comment on his thing, but they won't see it because he's hidden me.
So at least a little bit less lies in the world.
Holy shit, guys.
Yo, flirts.
Iran, get this, Iran has the largest shopping mall for individual shops with over 2,500 plus, covering nearly 2 million square meters.
Wow. Squares?
No thanks.
That's Euclidean.
I lost my car at the Mall of America, and it took me like 6 hours to find. I don't even want to think if it was bigger.
So to put that in perspective, Mall of America is 500,000 square meters, and this fucker's over four times bigger.
Fascinating. I'm going to go now. I'll see you later, guys. It's been fun. And tell Larry that he should. You guys should praise Larry much more than you do. You don't realise how honoured you are to have him.
Yay, Larry.
Sorry, I don't like venerating humans. I save my veneration for the one above.
Living shadow giants, I'm telling you. The only one.
Yeah, thanks for stopping by, Bob. This was a fun conversation. You can feel free to stop by anytime.
All right. See you again now.
So,
any sound?
Hey, Buster, are you there? Have you got your guitar?
Yeah, I've got it right here. I've just been working on something new. It's a song about looking for the truth. Play it for you guys.
What are you doing? I want your shelf level or not? And if I say yes, you're gonna provide that for me with that? Yes? See the bubble? I'm familiar with the bubble, Morty. I also dabble in precision, and if you think you can even approach it with your sad, naked caveman eyeball and a bubble of air, you're the reason this species is a failure, and it makes me angry. You wanna experience true level? Do you? Oh, that's in my mind for all to see. And it makes me angry. Choices will be made. You wanna experience true level? Do you? You can choose to let your mind be free. Wow, it's so. Oh my God. Oh Christ. Yeah, true level, bitch. I think that you're right.
Exactly, it's level.
Everybody knows that you're wrong. And it makes me angry. There are things wow, it's so. Oh my God. Oh Christ. Yeah, true level, bitch. In the end, you're fine. We're all looking for the truth. Save it for YouTube. I'll keep looking for clues. Wow, it's so. Oh my God. Oh Christ. Yeah, true level, bitch.
And that's my midpoint, 981. But look what I did here. And bam, there's the radius of the Earth. Using this bridge. Computing the radius of the Earth. 3 coplanar points in 3D would describe a circle.
You want to experience true level? Do you? True level, bitch. I'll keep looking for clues.
That's the thing, your vision is already being obfuscated by the spherical cap. One of the humps. Radius of the Earth.
Well, you seem to be in charge of what I get to remember. Why? Good question.
And bam, there's the radius of the Earth.
Yeah, true level, bitch.
Now we have our.
It has been directly measured. By Jesse Kozlowski.
You know, I got the idea from Bulip. I'm not kidding.
Yeah, true level, bitch. I'll keep looking for clues. Yeah, true level, bitch. Yeah, true level, bitch. Oh my God. Oh Christ. Yeah, true level, bitch. True level, bitch. All right, save it for YouTube. I'll keep looking for clues.